First, let me welcome everybody to this interactive session, and it is our great privilege that Dr. Shekhar Mande is with us and would like to interact with us in such a interactive and cozy environment. So Dr. Mande requires no introduction really, and here are the students, just to kind of give you the composition of the students. There are PhD students, there are master students, and there are BS students, as in BSM as those students. So there's all sorts of students in here, and with that, let me just leave it to you. Thank you.
Thank you. I don't know how to start, but to start on the lighter movement, I see that everybody prefers to sit behind and not in the front. The front two rows are. So when I give classes, I always find that the students prefer to sit on the back benches, and all those who are on the back benches, I ask them to come here, come here. Here.
Please front.
Here.
সামনের সিটটা ফিল করতে বলছো।
Come here.
সামনে চলে যান, আপনারা সামনে চলে যান।
So students are very afraid to come to my class because on the back bench I always call them on the front rows. Then you cannot afford to take a nap or something probably in the front row. The pleasure to be here. I don't know. I don't think probably any student would be here who was here for my talk last time. I gave a talk in 2019, if I believe.
Yeah.
The pre-COVID.
Students have already left.
Correct.
ESMS students not getting the opportunity.
Correct. 2019 is what I had given a talk. I had given a talk at that time specifically on the life of Kedareshwar Banerjee. So I don't know how many of you have heard of Kedareshwar Banerjee. Have you people heard of Kedareshwar Banerjee? How many are chemistry students here? You will be there for my talk today? So Kedareshwar Banerjee worked here. He was one of the earlier directors of cultivation of science in the 1930s. He came back from Dhaka. He worked for a while in Allahabad. He was a professor of chemistry in Allahabad, a professor of physics in Allahabad. Then he went to Dhaka, and then he came back to cultivation as the director. But that's not he is known for. He is known, and I'm going to narrate these incidents in today's talk, is that All of you know that in aromatic compounds, all the atoms are in the same plane. Do chemists will agree or they disagree? Agree or I see this, I see this. So do people agree or not agree? Yes or no? Yes. Okay. So it was not known in the 1920s that in all the aromatic compounds will be in the same plane. And in fact, the thinking was different. And there is a very famous lady called Catherine Lonsdale. Has anyone heard her name? Catherine Lonsdale? Catherine Lonsdale? Not heard of her name? Catherine Lonsdale was first ever lady FRS, Fellow of the Royal Society. She was also a social activist. In the First World War, she refused to go to war duty because British government had put the duty of war to the scientists, and she refused to go, because of which she was jailed, and she was in jail for 2-3 years, and she vehemently opposed war, saying that wars don't do any good. That's how her social activism was. But when she came back, she was a very strong woman, and she solved the structure of diamond for the first time ever. And eventually she also solved the structure of graphite. And she was the one who told for the first time ever that why do diamond and graphite two different allotropes of carbon? Have you heard of allotropes, carbon? Non-chemistry students? Non-chemistry students have heard what are allotropes? So why different allotropes of carbon have such different properties? Both of them are made up of only carbon, nothing else. Nothing else, only carbon atoms. And diamond is so because diamond is tetrahedral and is very closely packed crystal. All atoms in diamond are in sp3 this thing, right? And they are tetrahedral, and it's a very closely packed substance, and therefore it's very, very hard. Diamond density is about 3.5, right? I mean 3.5 times that of water. So it always sinks. While graphite is not hard at all, right? So graphite is, you know what all material graphite is used? Is there any common material in which graphite is used? Huh? Yes, you have to speak louder. Most people probably don't know. Pencils, the one which blackens is graphite. Okay, so that's not lead, unlike what you believe. There's graphite. So graphite is one form of carbon, diamond is another form of carbon. And graphite, because it's kind of a planar structure and at different planes they stack on each other, graphite can actually be very malleable and things like that. So she was the first person who described that to the world. She was also, as I said, first lady FRSS. She refused to go to the war, and I'm going to take a small detour here about the war. There is a person called Mosley. I don't know how many of you have heard of Mosley. What is he known for? Somebody has to speak louder. Even if you are wrong, don't worry, because science you can always go wrong. So,
periodic table.
Yes, not diffraction, X-ray absorption. But periodic table, yes. But what about periodic table?
The periodicity varies with atomic number, not the atomic mass.
That's right. Yes. Speak it loudly. No, I think you're speaking very low voice, so others did not hear properly. Periodicity?
Periodicity varies with atomic mass. I mean atomic. Sorry. The periodic table should be arranged on the basis of atomic number, not the atomic mass, which was previously periodic table was arranged with the gradually increasing atomic mass, but Mosley showed by the absorption spectra, the spikes in the absorption spectra, X-ray absorption, that the atomic number should be the correct parameter in order to create a periodic table.
That's right. So Mosley proposed a law. If you vary the wavelength of X-rays beyond a particular wavelength, the X-rays don't absorb, right? And that wavelength which characterizes beyond which X-rays won't absorb is a characteristic of atomic number of an element and not atomic mass. And Mosley therefore proposed that periodic table must be organized according to atomic number and not atomic mass. It was done prior to Mosley's work. There's sometimes in 1912, 1914 around that time. Now I'm telling Mosley's story before Catherine Lonzel's story because Mosley was sent to war. Catherine Lonzel refused to go to war, but Mosley actually went to the war and fought with guns and all, and he died in the Battle of Gallipoli. There is a famous war of the British and others, where the battlefront of Gallipoli he died in the war, and because of which the 1916 Nobel Prize was not given to anyone. You know, I mean, there are a number of Nobel Prizes that were given. One year it was given to the Bragg father and son. One it was given to Charles Barkla. But it was supposed to be given to Mosley, but unfortunately he died on that year. So that year Physics Nobel Prize was not given to anyone. And it brought into focus that you should not send scientists to the war. And British government took a conscious decision that nowhere again in future scientists will be sent to war front. So that's how Mosley was. But nonetheless, coming back to Catherine Lonsdale, she spent time in jail. She came back and then she solved a number of structures, and there's an extremely important contributions in terms of many different structures then, as I said, diamond, graphite, and many more later. Catherine Lonsdale was fascinated by aromatic structures, and she said that at that time benzene could not be crystallized because benzene at all temperatures is liquid. You have to really get the temperature really low to make it into a solid, and if you can't make it into a solid, you will not be able to solve the structure. And the only technique which was available to look at atomic coordinates was X-ray diffraction. So she said that benzene cannot be crystallized, there is a problem, and therefore if you have to study aromatic compounds, the best suited aromatic compounds will be hexasubstituted benzene, for example C6L6, Cl6, so hexachlorosubstituted benzene, or things like naphthalene and anthracene. Naphthalene 2 rings, anthracene 3 rings, but all of them aromatic, right? And at that time, a very famous person called James Robertson, and I'm going to give that example in the afternoon today, he solved the structure of naphthalene and anthracene. And in his structure, he showed that all atoms in naphthalene and anthracene are tetrahedral. This 1929 famous paper, he showed that this structure is tetrahedral. So, if carbon is tetrahedral, it will not be in the same plane. Right? Do you agree with me? If all the atoms are in naphthalene and anthracene were tetrahedral, they will not be in the same plane. Right? They would have different conformations like boat, chair, whatever. No? I mean, a simple 6-member ring, it will be boat or chair conformation. And that was 1929 paper. And that paper at that time was studied by others in India, especially Bhagwantam, who was looking at magnetic anisotropic studies. And he felt that there is something wrong in Robertson's structure. And then he requested Kedareshwar Banerjee, who we come back to Banerjee now, to look at the structure again. And Kedareshwar Banerjee solved the structure. And he published a paper in Nature. And he said that Robertson's structure doesn't fit into the ideas or rather the experimental data of diffraction, and therefore all the atoms in naphthalene and anthracene must be in the same plane. They cannot be out of the plane. That's what Kedareshwar Banerjee actually showed. That's one of his contributions. And I will show in the lecture today that Nature did not publish the paper straight away. It forwarded that paper to Robertson for his comments, saying that your structure is being challenged, what do you say? And Robertson opened up his comments once again in the same issue of Nature, back-to-back papers. The first line he says is, I believe Banerjee's structure to be essentially correct. So he accepted that is correct. So for the world of chemistry, those who are chemists here, you must remember that the fact that in aromatic compounds or in sp2 hybridization, all atoms are in the same plane is Banerjee's contribution. And Debye-Haskell theory came later. About 2 years later, the 2n+1 and all those rules that you have probably heard of, they came later. So the first evidence came from Banerjee. The second important thing that Banerjee did in 1933, he showed that in crystals, there's something called structure factors or amplitudes of diffraction, and these amplitudes have statistical relationships amongst them. He actually showed in a proper mathematical format. And that idea was eventually developed by others in the field, especially people like David Sayer and A.J.C. Wilson. And finally, the two people called Jerome Karl and Herbert Hofmann. So Karl and Hofmann eventually developed the ideas very much. And then they proposed what are called as direct methods, for which Karl and Hoffman got Nobel Prize much later. In 1980s, they got Nobel Prize for developing direct methods. And direct methods are the ones that routinely today, if any one of you ever solves a structure, has any one of you solved a structure here yet? Collected diffraction data and solved a structure? You have done that? You would have used what program? Shellix or something, or which one it is? Shellix? All programs use direct methods. Okay, Shellix or something, any program that you take for solving structure uses direct methods for chemical, the small chemicals. And direct methods are based, the origin of direct methods is Banerjee's equation. And Jerome Karl, in his Nobel lecture, when he was giving the Nobel lecture, he acknowledged that fact. The first reference he cites is that all the direct methods actually start with the work of Banerjee in Cultivation of Science in 1933. So you should be aware that, I mean, this kind of work has been done by people like Banerjee and India. So anyway, I can go on talking about history of science for a long time. Today also in my lecture I am going to tell you a lot of history of science. The principal objective of giving my talk on history of science today, and I am focusing only on biomedical science, is the fact that India has had enormously rich history. Okay, and when I say that in public platforms, especially places like Calcutta, I get very violent reactions from people saying that many of you speak pseudoscience, many of you actually glorify our history too much, the modern people don't recognize what happened in India and things like that, which is all junk, because I will show you documentary evidences that what kind of science has been done in India and how West deliberately tried to suppress that. The knowledge that was generated in India and how it was actually deliberately suppressed by the colonial powers then. And there will be documentary evidences. And documentary evidences have been not created by us alone. Even the Western people, when they were here, when they went back, they discussed these ideas in their meetings regularly. For example, Royal Society in UK routinely actually discuss ideas that were made in India. To give you an example, there's a process of making steel. Okay, when you make steel, what you do is you take iron ore, you combine with something like 0.1% or 1% carbon, and then you put it in a blast furnace. And when you do that, I mean, you get actually very good quality steel. Now, the standard process the British were using was something called a Sheffield steel process, which people like Michael Faraday and all were actually also seeing how to improve that and all. When the British came to India, they realized that the process of making steel in India is something called a wood steel, WOOTZ, wood steel, existed, and Royal Society sent a delegation to understand how it is made, and that actually turned out in the crucibles and furnacing and addition of carbon and things like that, they realized that this is actually much better. But this process in India had existed for centuries. Several centuries the process of making steel had existed in India, and in fact Indian steel used to be exported to countries like Middle East and all, and used to come back to India as finished products in terms of, you would have heard of something called Damascus sword. The swords were made, I mean, all the people then, including Tipu Sultans and the Mughals and the Marathas, they fought using the swords, and the finest of the swords were made in Damascus. And the Damascus steel went from India, they made sword here, and they used to actually come back and they used to do that. And then Faraday and all they recognized, and then when they took it back, the process, even the British steel making industry actually switched over to the way Indians were making steel. And I'm going to tell you some stories, not of steel today, but I'm going to tell you stories from biomedical literature, how certain things that were discovered in India centuries ago are even used in practice by our doctors in our latest hospitals all across the world even today. Okay, not only in India but all over the world. The practices which have been described in our text, they have been taken as it is, and they are also being used today, they are in practice today. That is an unbroken tradition of those practices, and that's not pseudoscience. Okay, I will give you an evidence of how it was actually taken to the West, who took it to the West, who did the first surgery using this practice, how did the first surgeon and gave an evidence that that person had learned it from India, and how is even practiced today, and I will give you all the show all the evidence. So the thing is, the reason for saying this is that there are two distinct opinions that are presented. On one side, people actually say that we have been always very glorious and therefore we don't need to adapt to the modernism. On the other side, the modernists always say that all that you are talking of is past history, and let us move with the modern methods and all, and let us not actually worry about what happened in the past. And this dichotomy we must break. There is so much to learn from our history, and for the people who understand history, for them so much to interact with the modern people and actually improve our lives. From both sides, it is actually great learning process that ought to be initiated, that how both sides actually come together and then bring overall benefit to larger humanity. That's the whole purpose of giving my today's talk. And those of you who are aware of Indian culture, when we talk of Indian culture, we always talk of what is called as the middle path. Buddha has described the middle path extraordinarily well. Those of you who have read Buddha's teachings would know Buddha always says that you have to follow the middle path. Don't dip, don't go there. And the debate very often in the society that you see, and you are actually very influenced by the leftist opinions here, being in Bengal, and those who grow up in places like US and all, they are very heavily influenced by the rightist opinions. And it's never whether right is right or left is right, it's always the center is what we actually follow. You know, and that's our traditional teachings, and we must follow our traditional teachings. What we have taught the entire world, today we have come to a situation that we have forgotten our own culture and what our teachings have gone all around the world, but we are not able to practice those. And that's one of the messages that I would like to give today in my talk today, that how do we actually always take the middle path, and how the middle path always benefits the society better. That's the overall lesson today. But I don't think I will bore you much with the history. I can go on talking about the history of science for a long time, many different examples. I also talked a few related to biomedical sciences today. But if you have any questions, I may be able to. Or any other questions? Not only on history or anything else that you think, life in general, whatever.
Thank you, sir. I just have one question. Sir, as you are the former director of CSI, so what is the vision of India? I mean, what is the vision of India in for the future scientists like us? I mean, you are talking about history, but as we know that India is still a poor country, so we have been paid by the poor taxpayers people. We have been well trained for the 5 years. For us, like there are so many chemists. We have trained how to synthesize molecules and how to make compounds like that. But what's the use? I mean, I'm the final year of the PhD student. So if you ask me that what should I do, I'm thinking about postdoc. And if you know the statistics, you find that the most of the people who go to postdoc, they are not came back to the India. So the poor taxpayers people come to the use of UK or Germany or US's service. So what's the vision to the people like you for the future scientists like us?
Okay. So I think there are multiple different aspects that you have asked in your question, same question. We'll try to see how best to answer that. Number one, if somebody studies here, goes overseas, and decides to settle down there, I don't think government or public should actually come into force an opinion that a person must come back to the country. It's true that our taxpayers' money was spent on that particular person, and the person was educated here, but as long as the person continues to contribute to humanity in general, mankind in general, I don't think we should take too much sorrow out of that the person is not doing much. This question is typically asked, for example, in IITs and IIMs, that amongst the most students who go to IITs, if you follow that how many have really become engineers in their career later, there's only a small fraction. I mean, you'll be surprised that out of every 100 student which goes to IIT, irrespective of civil engineering or mechanical engineering or electrical engineering, only 10% of them remain in that particular branch. Most others actually move to either they become IAS officers or they become managers or they start their own companies or something. The question that people ask, is it worth spending so much money in generating so many different engineers? And the answer always is emphatic yes. Because we must actually give exposure to our students in whatever they like to do and develop as human beings in whichever settings, whether it be in IITs, whether it be in universities, whether it be in colleges, or whether it be in institutes such as this. We must try to give best exposure to the students, and then student must exercise free will, right? His or her own free will on what he or she would like to do in a career later. When you come to institutes like this, the essential idea is that we will train you so well and we will give you a broader perspective of everything, and with that broader perspective you choose what you want to do, and I don't think any government should interfere in your choice of what you should do. So I being in CSIR, if as a Director General of CSIR I had said that every student of CSIR must come back and work as a scientist in the country, I think that would have been very unfair. So it's not right for me to say that I have spent money on you and therefore you come here. Alright, so basically students must have their own free will. For example, if someone like Chetan Bhagat, right, he is an outstanding author, but he studied in IIT Delhi. Now, has the education gone completely wrong on Chetan Bhagat? Was it wrong to spend money on him? Not really, because the kind of exposure that he got being in IIT Delhi and kind of different sections of society and some of the brightest students around actually made him a better author, is what I would like to believe. So that's exactly the thing, that when government spends money on education, is rather preparing students to become future citizens of the world, and irrespective of where they stay or irrespective of which path they choose, I think they should contribute to humanity and the world in general. Right? I mean, that's the view that I take, and that's my personal view. Similarly, government also takes very similar view. Government doesn't actually make you sign bonds that we have spent so much money, so you must do this after you are finished or something like that. And that's, I think, a reasonable view. But the path that many of our students do, and that has been debated for the last few years in Delhi, is that most of us, when we are actually teaching students, especially at the PhD level, most of us, about 99% of us, are actually trying to create a mirror image of ourselves in the students. When students come to our lab, we teach them our field, we try to teach them the best thing in what we have actually learned over the last 20-30 years, and we are essentially trying to create an exact mirror image of ours. Now, whether that is right or wrong is debatable. In fact, there are so many other things that are exciting opportunities that exist for the students later. Many times students are actually not aware that beyond doing PhD and a postdoc and coming back as faculty in one of the academic institutes, beyond this there are many other options which are there, in which a student can actually contribute extremely well to the development of mankind in general. One of the failures of ours, I mean including myself, has been we have always tried to create mirror images of ours, and we have not given sufficient exposure to the students on multiple things that actually exist beyond either your MSc or PhD or whatever. We have multiple choices that exist in which the student can really excel well in those choices. If the student were to adopt that particular choice, would do well. So this in a nutshell. And chemistry, because you said, I mean, India is ranked one of the top few nations where the chemistry is so strong. There's one area of science that you can actually count on in which Indians have done extremely well is chemistry. It's one of the very, very few areas where Indians have done over the years really very well, including the present times.
Yes, sir. Thank you for your insightful talk. I really enjoyed that. So I have a quick question. So if you look at the US model, so they have something called the NSFRU, which is equivalent of like summer projects or research exposure to undergraduates, those who might not be pertaining from a very good institution where research is very valid. We have a similar analog in India, which we call the IAS, or the Indian Academy of Sciences, but that is not really widespread, or that does not entail as much capacity of students or on a scale compared to the NSFRU. So is there any planning on part of that, or how can we at all impinge research at an undergraduate level at large, even broadening our mindset outside the regular research field that we look in around in our institute?
So what has happened is that over the years, when we started with the Indian Academy of Sciences summer training program, and that has turned out to be successful. But as you correctly said, it's a very limited extent. It's not been scaled up to the extent that we ought to be doing that. You know, we also look at the kind of aptitude of a student who would be inclined to do research or has an aptitude to learn more or contribute to knowledge more or something. And many students will not have that kind of an aptitude. They would have aptitude for something else. You know, so we must actually also recognize that particular aptitude and promote that particular angle of a student. I will give you an example in a while. But the thing is, what Indian Academy of Sciences started about 20-30 years ago was adopted by a few other institutes a little later. Now many institutes actually offer summer training program in their own design. Many universities and institutes, for example, Jawaharlal Nehru Center in Bangalore also has similar summer training program. So they also offer fellowships and all. When I was in CSIR and we were going through a difficult pandemic era, we decided that we will offer online training to the students. And for 2 years, we did that program, summer training program for students online. And because it was online, we could actually scale it up. That online, I mean, there is no constraint like lab space or something like that, right? So there, in the first year, we had something like 16,000 students who came, and we arranged talks for 2 months. Every day there was a talk by someone about a different thing, including Nobel laureates and all who came there. And there was a very successful program. And we were able to send even the certificates to the students who had attended all talks and things like that. The issue for all of us is always the issue of scale. In India, our numbers are so high, and the number of academic institutions is not that many who can accommodate so many students. So the issue of scale always hampers our spirits. But that is kind of offset by the fact that not all students have inclination for particular research aptitude or whatever. So at least that works in our favor. But invariably there are many students who would have liked to do summer training and don't get an opportunity to do that, and which is sad in my opinion. So we have to try to find ways now that how do we actually provide opportunities to all these students, right? That's one thing. Now I thought I will tell you a very interesting example about training in the lab. So when I was in CDFD, the Center for DNA Fingerprinting and Diagnostics in Hyderabad, I was a scientist there. We had signed an MOU with BITS Pilani. So I was the Dean of Academics there for a long time in CDFD Hyderabad. And we had signed MOU with BITS Pilani saying that your students can do 1 year project with us. So the dual degree of BITS Pilani, they have 1 year project in the final year. And routinely many students used to come to CDFD. I mean, every year they used to send something like at least 5-6 students, so CDFD Hyderabad, and they would be placed in different labs and all. So one fine year, I got a student who was a dual degree, one of the engineering degrees and MSc Physics, and was doing training in my lab because my lab was working on the interface of physics and biology at that time. I found that he would hardly come to the lab. And whatever project we were doing, he was actually trying to analyze protein interaction networks using graph theory in my lab. He wouldn't do any of the things. He was not even learning graph theory. I was trying to teach him graph theory and his interest was very low. So one fine day I told him that, see, you have to finish your project, and if you don't finish your project, how am I going to give you a report that you have done satisfactory work, and how will you go back and get your degree? So then he told me, "Ki, sir, my intention in life is not into academics. I don't want to do any more engineering or physics or anything in future. I want to be an entrepreneur." I said, "By all means, be an entrepreneur. I don't think I would be able to stop you being an entrepreneur. But at least prepare some kind of a business plan, and I will tell you, at least run it through to the friends who are working on financial models or mathematics and all, whether the business plan looks alright and whether it's viable or something like that." And he said, "Sir, that I will do with great happiness." So he prepared a business plan and he gave it, and the business plan was outstanding. What he had actually prepared was very good. So we could clearly see that his idea of not being a scientist but being an entrepreneur was well placed, and we had to make sure that that idea is promoted, not to suppress him. I told you some time ago that we are trying to create our mirror images in our lab, and this is exactly what we wanted to avoid. That if here is a bright young student, wants to be an entrepreneur, has brilliant ideas, then why not promote them? So we told him that by all means you do it, and I will give you a very favorable report for your project. That's what I did. Then we lost touch for several years. About 2 years ago, some of my students came to me and he said, "Ki, sir, do you know who owns Swiggy? Who started Swiggy?" I said, "I don't know." He said, "This is the fellow who worked in my lab." Okay. So he is the owner of Swiggy, and all of you have such. His name is Nandan Reddy. He did project in my lab for 1 year. So if you do Google on Nandan Reddy, you will find him. So, but I'm so happy that eventually he was successful. He started his company. We are not able to dampen his spirits, and he found his satisfaction in what he is doing. I hope he found his satisfaction. So what you people must learn is find your own aspirations. You know, this what will happen is that many times, as I said, most of us, which includes me, we are trying to create our own images in the students, and we'll encourage you to do postdoc, we'll encourage you to take academic jobs or something like that. But if you find that your niche is not really that, and you really want to do something else, by all means do that. Don't be dampened by the spirits of your supervisors or your parents or teachers or whatever.
So I have one more quick follow-up question to that. So in continuation to my previous question, so again in the US we have something like an IACS symposium, where like researchers of all stages in their career do assemble on a common forum to spread and interact science. So can we have a similar analog in India, a common forum for researchers, like right, starting from the undergraduate level, postgraduate, senior scientist level, coming together on a single forum in sort of
So the number of conferences which take place every year in different fields. So I am a member of the Indian Biophysical Society and also Indian Crystallography Association. We have an annual meeting every year. So all the biophysics students actually come there and present their posters and things like that. Recently we had a meeting in NCBS Bangalore on the biophysics. But similarly for chemistry there is CRSI, or there is for materials there is a MRSI. These societies, they also have annual meetings. And many students go there. And what you should just find it, what conference is actually being held. And these conferences are actually very well attended also by the students. For the biochemistry there is something called Society for Biochemists in India, so it is SBC. And these are very, very well attended meetings. And many students go there, they present their posters, they get to interact with people and all. So they may not be on the same scale as IACS, because IACS would be attended by a few thousand people, while these are attended by a few hundred people. But nonetheless, there are meetings where students can actually go and attend.
However, like the representation of undergraduates in particular, because since I am an undergraduate student as well, I really feel the lack of undergraduate representation in several of such meetings. So
I think you should apply. When you are a chemistry student or a material
yeah,
science?
chemistry.
I think you should apply for the CRSI meeting next year. And I'm sure if you register, they would allow you to attend it. There's a question here.
Sir, thank you for the inspiring talk. And actually, I have total 3 questions. First one, little bit academic, little bit scientific questions, and then couple of I will ask you for a couple of questions what we are facing as a PhD students. And my first question is what you have what you said about the crystallography. Then you said that actually we know that crystallography is the periodic arrangement of a crystal is a periodic arrangement of atoms or molecules or any constituent particles or something like that. So my question is, if I know the positions of the particles or atoms or any molecules, then I don't have any other data or any other inputs of like that. So can I predict the crystal structure or space group of a crystal structure? Can I predict that?
So this is a very active area of research at this moment to predict structures. In fact, recently there is a paper in Nature from University of Liverpool on using methods of artificial intelligence and all, and how we can actually predict structures, okay, of small molecules. If you work on large, more complex molecules, for example proteins or something, recently Google has come up with a method called AlphaFold 2, and that helps you predicting structures of proteins. So, but still I would say that it's a very, very active area of research. The people do, for example, in Bangalore there is a person called Umesh Wagmare, who does a lot of DFT calculations, and he is trying to actually predict structures using DFT. So, a lot of people are using different methods and trying to optimize what is the best way of predicting structures using those things. So, that's a very active area of.
Yes, sir. Actually, in the school days, what we have been taught that the crystal is a periodic arrangement of atoms. Also, we should at least predict the crystal structure from the atoms, from the positions only, right?
People are trying to do that. At this moment, the success has been reasonable, has not been fantastic, but it's a very, very active area of research around the world.
Okay. And sir, actually two more questions that we are facing. We are facing issues as a PhD students that actually when there are very limited funding agencies in the central government for attending the overseas conference. So actually we are applying for the funding. We are applying to the funding agency, but we are not getting that too much money to go to attend the overseas conference. So in these circumstances, can you say something that like what we should do or something like that?
There is a true fact that indeed the amount of funds available to students to attend international meetings is very limited. DST, CSR and all have some funds, they are very competitive, and the funds are not sufficient for everyone to go. When I was the director of National Center for Cell Science, or when I was the dean in CDMT Hyderabad, we had actually made a point that every PhD student in our institute, both in Hyderabad and NCCS, would get at least one supported conference to attend. So that tradition continues in NCCS even today. The National Center for Cell Science in Pune, where I was the director, that I had set this practice in 2011, that practice still continues, that student in a 5-year tenure would get to attend at least one international conference, which will be financially supported by NCCS Pune. And the same thing we have done in CDMT Hyderabad. And I believe similar thing also exists in places like TIFR or NCPS and things like that. I don't know whether
We have also.
here also. At least once in your tenure of 5 years, you should get support here.
Actually, sir, one more issues we are facing that we are not getting the fellowships in every month.
I had asked him before walking into the room, is this question going to be raised? So I will tell you the fact that when I went to Delhi in 2018, there was a huge backlog of fellowships. The average backlog was something like 9 months or 10 months or something like that of distributing fellowships, and it was a very challenge for all of us. The problem essentially was the bureaucratic handling of the fellowship papers. You know, our bureaucracy demands that student must record present or absence every morning, right? Then we looked at the guide. And the guide at the end of the month certifies that the student has been present in the lab for so many days in a month. Then that goes to the dean, that goes to the director, and that goes to CSIR. The CSIR, some clerk decides that all the days have been attended by the student or not. Then the bill is made and forwarded to someone, and then check is written by someone. It's unimaginable bureaucracy. So we tried to reduce that, and at least in CSIR what we did is to make things easier, we actually made a portal in which student would actually see how soon they have done. So the delay was brought down from an average delay of about 10 months. So when I left last year, the average delay had been brought down to something like 3 months or something, 3 or 4 months. So I don't know whether that still continues or not. So
Since then, things have been.
yeah, but I still feel that even that is not acceptable. What as a DG I would have liked to see is that just like any other employee of the government receives for the first day of the month salary, the student should also get salary on the first day of the month.
Yes.
That's exactly what we are trying to work for. But I don't know if you're all the people that's really the first priority or not. I mean, for me, that was a priority to solve this particular issue. I did not solve the issue completely well, but at least to some extent I was able to improve the situation. But that problem continues, unfortunately. But I hope the delays have come down now. At one point of
That's
time,
true.
the delay has been partially caused because the government at one point of time, and don't put me outside this room, implemented what is called as a direct benefit transfer. So the fellowship comes into students' account directly from the government. Alright? Now, when I was the director of NCCS Pune, what we had said at that time, direct benefit transfer did not exist. Alright? So CSR used to send money. And CSR will send some 1 crore rupees or something because their salary of next 4-5 months or something like that. And we will be able to in a position to distribute that. What we used to do is that we made sure that every student gets salary on the first day of the month. Alright? Irrespective of whether CSR or EDC have sent money or not. And then we would actually then collect all the bills and send those bills to CSR saying that so many students for the past few months we have given salary out of our core budget. So please reimburse that. In fact, today also in my bag there will be a paper that I am carrying to CSIR when I go back from here to Delhi, that NCCS says so much backlog is still remaining, about 2 crore rupees backlog which is remaining on CSIR. But we made sure then as an institute that student would get salary on the first day of the month. So that was one of my achievements in NCCS 7 years that I was. All the students were getting their salary on the first day of the month, and then we used to raise the bills with CSIR. CSIR would process the bill and send the money to NCCS. So we would actually recoup that money from CSIR sources then. Unfortunately, with direct benefit transfer, you can't do this. No. So there has to be some other way of solving this particular problem. But our objective in the long term for all the science administrators should be that student must get salary on the first day of the month, every month. That should be the real objective.
For an institute like ours, this direct benefit also create a little problem. Our students normally get their institute funded students get their fellowship on the first year. As a result of DBT, what as you say, we also used to follow the same thing. So we also used to follow the same, that we used to take our own money and pay that and then eventually raise the bill and submitted the claim bill to CSIR. But since that part is now gone, we cannot help the CSIR or UGC funded students other than our institute funded students. So this is the negative side of the DBT for the institutes who are proactive in dealing things. But for university or other systems, probably that had made a better impact because they obviously don't have enough money in their capital grant to give their salary.
No, so I will tell you one side story once again. I am not to be quoted outside this room. There's a committee formed under my own chairmanship, and there were representatives from all the funding agencies, Ministry of Education, UGC, Department of Biotechnology, DST, Inspire and all. I was the chairman of the committee, and we actually made a recommendation that for the PhD fellowships, we should not do direct benefit transfer, but we should promote this particular system that in advance, all the funding agencies, the UGC, CSIR, Ministry of Education, everyone will park that particular year's funds with the institute, and institute should give that money. So that was the recommendation, which was accepted by our minister, Dr. Jitendra Singh. He said that it's fairly transformative, and he actually accepted this thing. It went to Ministry of Finance, and Ministry of Finance had some difficulties. But by then I also retired. So.
That's a good question. So, is there really need for this incredible?
একটু মুখের সামনে দাও।
Essentially, is there any need for this incredible bureaucracy that you mentioned? That there are so many steps. I mean, some checks and balances are of course required. We all agree, but
Okay, so in my opinion, you don't need this bureaucracy. In my opinion, you take yearly attendance of the students, and once in a year, you send that this student has attended so for so many days. That should suffice. But convincing people at a particular level is always a challenge, and even person like me could not actually have my own opinion forced on many other people. But there has been a lot of criticism about direct benefit transfer. We see one aspect of direct benefit transfer in this particular audience, which is small. Or if you take all the research scholars in the country, on today's date, CSIR supports about 8,000 research scholars in the country. UGC supports another 4,000 and something like that. At best, all funding agencies together, we support about 20-25,000 research scholars in the country every year. Now that actually is a minuscule number compared to several lakh students in schools and colleges which get a scholarship from the government. There are many other things at a college level and all. There are many Ministry of Education, for example, for Northeast, for socially deprived classes, and so on. So there are a large number of fellowships that students get, even in the schools and all. And what was realized was there's a big scam which was going on, that the money, when it was being transferred to that particular school or department or something, the money not always was delivered to the last student which was there. Okay, so that thing actually came up, that where was the money going, and as you don't have to make very intelligent case, you don't have to be very intelligent to make a case where the money was going. And therefore the government actually came down heavily that the intended beneficiary must get the entire amount due to the beneficiary. And that's why the direct benefit transfer was started. And it has actually changed lives of so many people there if you look at rural areas or very far off places or northeast and all, it has indeed made a big difference there, direct benefit transfer. But community like ours, where number is small, are kind of adversely affected by that.
Thank you, sir, for the talk. Circling back on something that you said, how researchers or PhD supervisors are focused on making mirrors of themselves out of students. So, for a research institute or an institute like IACS, what is your opinion on having a placement cell for such? Because we don't have it. See, a lot of students who join in the BSMS program, they are fresh out of school. You really do not know what you want to do with your life at that point, right? And you think you want to do something, but maybe in the course of 5 years, your opinion might change, or what you want to do with your life might change. Or someone might even want to go to industrial research and not just academic research, right? So for students and even for PhD scholars after PhD, shouldn't there be an opportunity for students to explore other areas after being exposed to obviously research and the research culture? Shouldn't there be a placement cell as well in research institutes for students who want to explore other areas? I just want an opinion of you.
So placement cell or not is a difficult question, because being a small place, unlike let us say IIT or something, placement cell may not always be possible for institute like IACS. I don't know what IACS what it does, but the fact is that students should be exposed, right? What are the options after doing your formal education here? Those kind of that kind of exposure must be available anywhere you go, and I do believe that institutes like IACS can actually once in a while bring some very creative writers here, or people who are very good in entrepreneurship, or people who have become successful lawyers after becoming scientists, or people who have actually even taken to public life. So if that kind of exposure is available, I think it would do well. So institutes like IACS should once in a while bring people, not give courses, but at least arrange lectures for people who have had very successful science background but have made success in some other area of their thing. So for example, in Maharashtra, there is a very famous playwright called Satish Adekar. He's a very famous person. He writes dramas and all, and his dramas have become very famous, and there are very socially relevant issues that he actually writes about and performs all over the world, his dramas and things like that. He's actually a biochemistry graduate, but he has made a very successful career in writing dramas and things like that. We have 2 or 3 very good examples of politicians today who have science background, right? And they have made a very successful career in politics later. We have large number of industrialists who have a science background, and they actually started industry on their own. And I give you example of Nandan Reddy. So these kind of examples are plenty in society. The fact is that how these examples actually are brought to you and you are made aware that this kind of opportunities exist after you finish your formal BS, MS or whatever is something that institute can look into.
Sir, one more question. So, as you have said the story of the Swiggy, so from that point of view, I want to discuss that I have interacted so many friends from IACS. So they have also very creative idea to start new startups, entrepreneurship like that. But we don't have such a platform in the research institute to do that. Even we don't. Most of the people even don't know what is entrepreneurship particularly. So don't you think that every research institute should have a incubation center like that, so that that idea or that creative mind should be explored more? There will be large example of Swiggy like Swiggy.
Yeah. You have to also remember, Swiggy is a successful example, and therefore I could talk to you about that.
Yes.
Okay. For every successful example, you'll be afraid, scared that how many unsuccessful examples exist. But that doesn't mean that you should not try. You know, I mean,
but try to where? I mean, we have no platform where to put the creative.
So the thing is essentially for being a successful business person or successful entrepreneur is not only to have that particular idea, which is actually maybe based on science, but also whether the market would be willing to accept that, whether you will be willing to raise money, or the people who fund such ideas would be willing to put their money on your idea or not. How do you convince people that you need working capital to begin with, right? And at the end you need a finished product which has all the proper quality assurances and all, whether all of it actually you have worked out or not. Okay, and this kind of training, typically what happens is that institutes like IACS or something, because you don't have a business cell here. Tomorrow somebody will say that I want to become an IP lawyer, and IACS obviously cannot have an IP law department or something like that. So institutes like IACS will always have an inherent difficulty, because being small institutes, that they will not be able to offer you all of these together. But what you must explore are places, for example, like IIM Calcutta. IIM Calcutta is meant for that, right? And if you are really interested, you should try to do a management course in IIM after you have finished your PhD or whatever, or you have finished your MSc or something like that. Or come up with people who are fresh graduates of those institutes, come together and form a team of 2 or 3 people who are actually good in finance or finance raising, people who are good in making business plan and things like that, and your ideas and things like that. So teams always work that way better, that coming together and proposing that. But institutes like IACS will always have difficulties in promoting that. IACS definitely can have an incubator. There's beyond doubt that if IACS had an incubator as a Section 8 company, and IACS were willing to incubate companies based on the ideas that it feels appropriate, I think that would be something very good. And these days what has happened is that many of the IITs and all have started incubators. So in fact, some of the best incubators are, for example, IIT Chennai, I don't know whether you have ever gone there, they have a research park, or IIT Mumbai have something called SINE. They are very successful incubators in which IIT students themselves have gone and started their own ventures and all. But Nandan Reddy, when he was in my lab, he didn't go to any incubator. He just started a company along with a couple of his friends, and they started Swiggy at that particular point.
So in this context, let me update you. Our new director has really thought about this particular aspect of incubation center. And there will be a lecture, as many of you will also be asked to attend that. The CEO of one of the IKT knowledge park in Hyderabad will be here on Sunday. And you will have the opportunity to interact with her. So there will be a session. You will soon receive an email. Next Monday.
Good afternoon, sir. With due respect, I want to draw your kind attention to the fact that
if I'm not wrong, to the best of my knowledge, the CSR fellows are not getting the adequate amount of HRA. They are getting exactly 24%, while the other funding agencies, they are providing 27% HRA. So this is one fact, and there has been an OM from CSR from 1st July 2021 that they will provide 27%, but still you are getting 24% of HRA.
I think it should be raised with CSR, right? All of you collectively read through the institute.
Yeah, sir, we have.
It should be raised with CSR. I mean, if
but
it's
they are
wrong,
not
it's wrong.
responding, sir.
Huh?
We have already called them, and we
No,
have
calling doesn't help. You have to write a formal letter that your institute must forward to CSR.
Not all the CSR, I mean, all the CSR fellows. It's not a problem of the institute. All the CSR fellows are getting 24% of HRA.
Yeah, but it's an institute problem, right? Because institute hosts CSR fellows, and institute should raise the problem with CSR, and institute should duly follow it up. If it is according to rules 27% to be given, it should be 27%. And institute must follow up with CSR that all the fellows who are hosted here must get that kind of HRA.
Sir, I have two questions. First one is more of technical and second one is general. So the first question is, you talked about artificial intelligence and graph theory and chemistry and biology, etc. I personally do not have any background in chemistry or biology because I haven't studied them since class 12th. But I'm working in mathematical aspects of machine learning. Currently what I'm seeing in related papers are they are just getting the data and they are applying some model and getting some result, and most of the papers are like that, just picking up some model without like knowing the background of the model. Many people are doing like that. So currently there is a new paradigm called variational or generative modeling, where we have a limited amount of data, which is quite naturally in natural sciences because the data is quite expensive and time taking to me. So generally for machine learning we need lakhs of data. So what generative modeling does is it just creates similar kind of data, with some mathematical techniques. And my question is, I saw a lecture in ETH Zurich, and they told that they're working on such kind of problems. And they're saying it is really cost effective than solving finite element analysis and doing partial differential equations. It is way more cost efficient and time efficient. So is there any ongoing research in India in scientific field like biology or chemistry?
Oh, there's plenty of research that is going on right now. In fact, within Calcutta, if you go to a place like ISI, there's actually a full group of people working on these kind of problems. Yeah, I mean, not only regenerative learning, but many other things that actually people are looking at. In fact, regenerative learning is not a new idea. It has been used for ages. For example, in speech recognition and all, where the data is not very thin, speech recognition actually was done using these kind of ideas with limited data, and they were actually trying to fill it up. So, but there are some excellent groups in places like ISI that you should actually try to see whether they can say. But also good groups in TCG Crest here, which is not very far away from here, or ISER and their Applied Mathematics department. So there are actually large number of people in India who are also working on this thing. And in fact, you would know that some of the groups in India have made some fantastic contributions over the years in this. I don't know whether you are aware of the work of someone like Maninda Agarwal and his students and all. They've done some fantastic work in some aspects of this. Or Muthukamali's Vidyasagar. Vidyasagar has done a lot of control theory work and is an international dada in that actually, really. So there are a lot of people who have actually done very good work in these areas even in India.
So in CSR industrial level or proper scientific research, do you prefer this, like if I have limited number of data, generate new data from this without conducting an experiment?
No, it depends upon what problem you are addressing. You know, different problems have different solutions, right? For example, you are doing reinforcement learning,
yes,
right? Now reinforcement learning, actually your target is well defined. Where you want to go from point A to point B, and then actually you can start learning on your own, even if data is less, but you actually know which direction you are going to move or something. But whether that will work in every area, we don't know. You know, so therefore all this kind of different machine learning methods have simply come up simply because the different problems require different kinds of solution. And incidentally, I don't know whether how many of you know that the origins of all of this essentially it starts with statistics, right? Multivariate statistics. So all the machine learning actually begins by teaching people the different techniques of multivariate statistics. For example, linear regression and all that is actually taught in the first thing before you go to machine learning. And all those methods were discovered in Calcutta. I don't know whether you know of that or not. And do you know the person who made these methods available?
Sierra.
You have heard of Rao-Kramer inequality? And all
That's the Rao-Kramer inequality and Kramer wanted the foundations of hypothesis testing.
Correct. Correct. So all of those multivariate methods which are predecessors of machine learning, what we call today, or what other popular language people would call artificial intelligence. In fact, you have to remember that artificial intelligence and machine learning are not the same thing. Okay, I mean they're very different things. So the origin of all of that is Calcutta. Sierra's work on multivariate statistics that he started here is the origin of all of that.
And the
Actually, it's quite late. Okay, so let's thank the speaker. No, that's let's thank you, Dr. Rambe, for actually patiently listening to so many questions and answering. Thank you. Thank you, sir.
কিছু কিছু জিনিস এসে যায় স্পন্টেনিয়াস, ভাবিনি যে এটা আসবে, আবার হওয়ার চেষ্টা করছি। খুব সুন্দর জায়গাটা দেখুন, আহা মোকলাতে এসে পড়ছে, কিন্তু তেহাই লাস্ট নোটটা মোকলাতে এসে পড়া একটা ইউনিক কনসেপ্ট হয়, আর তেহাই শেষ করে মোকলা ধরা একটা কনসেপ্ট হয়। দু রকম কনসেপ্ট হয়। এর সেকেন্ড কনসেপ্টটা খুব আন্দাজ দিয়ে চলে।
করাক না, দেখছি তো।
Respected Professor M.M. Sharma sir, respected Dr. Shekhar Mandi sir, respected Director Dr. Ranjan Shin, respected Registrar Ms. Sharbani Shaha, honorable dignitaries, faculty members, students and my dear colleagues. Good afternoon and welcome to the 148th Foundation Day celebrations of the Indian Association for the Cultivation of Science. Saturday 29th of July 2023 was the 148th Foundation Day for IACS. However, the celebrations are being held today. We will start today's program with a welcome song to be performed by the students of IACS. The participants are Ananya Sinha, Ankona De, Agamoni Ghosh, Nandini Das, Konark Bhomik and Antara Paja.
Hello. Hello. বাজে
We humbly desire to welcome and felicitate our guests today. We request respected Professor M.M. Sharma, respected Dr. Shekhar Mande, our director Dr. Ranjan Shin, and our registrar Ms. Sharbani Shah to kindly come on the stage and take a seat. I request our students, Tomali and Devapriya, to welcome and felicitate Professor M.M. Sharma. We welcome Dr. Shekhar Mande sir. We now welcome our director, Dr. Ranjan Shin. We will now welcome our registrar, Ms. Sharmani Shah. On this special occasion, may I request Professor M.M. Sharma to kindly say a few words.
Professor Sen, Dr. Shekhar Mande, Registrar Sharbani, who is always at work day and night in the service of IACS. I have very fond memories. How should I start? I am at home. That's the best way I can describe. I am so delighted to be present by coincidence on the Foundation Day. I am particularly pleased with the performance parameters of IACS and getting Fellowship of Academies, getting other awards, figuring on the prestigious page of Angavendi Shemi, I think brings a lot of laurels to IACS. IACS is doing so exceptionally well that I think it's time that gets better known in the country. Many attempts have been made, but these attempts must continue because people don't seem to know the outstanding performance of IACS in terms of publication, PhD per faculty member, apart from the fact that only Nobel Prize in Science came out of Raman effect work done in this very premises. In fact, I was making a suggestion at the time of lunch that IACS should prepare a compendium of major developments in Raman effect. That Raman effect has now gone even for security systems. And it's like NMR. Raman effect has brought so much prestige, and I still recall that British Museum wanted this to figure, and we had to send with special permission the original instrument for display there. One of the most outstanding feature in the recent past was, first of all, at taking this integrated course. So it is now both research as well as an educational institute. And even more striking is the intake now for the integrated course. Very significant number of students are coming from all over the country, including women. I think it is a very great achievement for IACS, and I'm particularly happy to see this particular development. I wish that, of course, nobody from DST is here, but surely you can convey this message that it is high time that they release money for Baripur campus. It is a pity that such an extraordinary institute has such a limited space, whereas all other adjoining institutes, including the CSR lab, both the labs of CSR, which have much, CGCRI is a huge area, and somehow IACS was left high and dry in terms of the area. But Baripur was a whip of fresh air, but unless they give more money, and that we honor one of the founders. In fact, what I will fail in my duty if I didn't pay tributes to Sarkar and all the initial persons who really made this place so great. Of course, along with the glory, there is also a continuing problem of legacy. It's not easy to solve, but I trust that the new director and the new chairman of the council are able to put all their efforts to see the legacy problems of IACS are solved. Foundation is so strong that after 148 years you are performing. It's not like performance once upon a time. It is a continuing performance and year after year improvement. So kudos to IACS. I wish IACS much brighter future. Brighter it is already, but much brighter future in coming years. Thank you. And I'm delighted to be present today by very strange and interesting coincidence. Thank you.
Thank you so much, sir, for your kind words. Now I request our director, Dr. Ranjan Shin, to give the welcome address.
My dear students, distinguished guests, Professor M.N. Sharma and Dr. Shekhar Mande, dignitaries, friends, colleagues, ladies and gentlemen. Professor Sharma has given a wonderful introduction about IACS. I will just make a formal presentation as director. So I welcome you all to our institute IACS on the occasion of 140th Foundation Day celebrations, which is being held today owing to the fact that 29th July this year was a Saturday and also a national holiday. And also we wanted to have a bigger participation by all the members of the IACS family. It is the day we present our institution and its activities to the guests, dignitaries and participants present in the program. It is also the day when we pledge to take our institute to a greater and more glorious height. IACS is the oldest research institute of its kind in India that was established by Dr. Mahendralal Sarkar with the vision of igniting a culture of scientific pursuit in colonized India. It is now an autonomous institute and is primarily funded by the Department of Science and Technology, Government of India. Government of West Bengal also continues to provide financial support. In 2018, the Education Ministry, MHRD, Government of India conferred a deemed to be university status to IACS, allowing the IACS to start a bachelor's master's program in science, along with master's integrated and master's PhD in 6 disciplines of basics and applied sciences. To quote our founder, the great visionary, Dr. Mahendralal Sarkar, the objective of the association is to enable the natives of India to cultivate science in all its departments with a view to its advancement of original research and with a view to its varied application to the arts and comforts of life. Even today, IACS is dedicated to the realization of this undying dream of its founder and its compatriots. IACS starts its journey from the campus at 210 Boboza Street, Kolkata, from where it moved to its present campus in Jadavpur in 1950. IACS is now committed to building its second campus at Baruipur Research Hub, which will be primarily focused in interdisciplinary research and our university. The salient features of the activities that we do in IACS are: we are primarily a research university conducting graduate, postgraduate and postdoctoral research. We impart advanced level teaching of postgraduate and selected undergraduate students. High quality research by a group of faculties leading to PhD degrees. Research in the areas of natural sciences, physics, chemistry, mathematics, computational and life sciences. We emphasize research in fundamental science and its applications. We ensure complete freedom for our faculty to interact with private industries and undertake consultancy services. Our institute has a very rich and glorious history. The latter half of 19th century witnessed an intellectual renaissance in the undivided Bengal. During this era, almost no noteworthy institution was there in the country to impart quality education in science and culture. Several eminent personalities from diverse disciplines committed themselves to the cause of institution building. One such personality was Mahendralal Sarkar, who was educated as a medical practitioner but with a mission to establish an institution to cultivate science. Dr. Sarkar devoted his whole life to the institution which he created and equipped with the hope that it should someday be utilized for the advance of science in India. The first trustee board, comprising of persons like Pandit Ishchandra Vidyasagar and Keshav Chandra Sen. The original mandate of delivering lectures in science was materialized soon when the father Lafont, Jagdish Chandra Bose, Ashutosh Mukherjee and Chunilal Bose began teaching in the association. Sir Ashutosh Mukherjee was described as the spiritual son of Dr. Mahendralal Sarkar, the dawn of scientific research efforts in India. It gives us great pride to remember that IACS is the very place from where Sir C.V. Raman was awarded the Nobel Prize in 1930 for his monumental research in physics, the discovery of Raman scattering of light. Professors Meghnad Shah, Satyendra S.N. Bose, K.S. Krishnan were some of the other luminaries who had adorned the ranks of IACS. The institute pursues relentless theoretical and experimental research in the fundamental and basic sciences, with an emphasis on translating its discoveries into technology wherever possible and training and preparing the younger generation to handle the challenges of the future, be it in the emerging areas of science or technology. IACS currently has 6 schools: School of Applied and Interdisciplinary Sciences, School of Biological Sciences, School of Chemical Sciences, School of Mathematical and Computational Sciences, School of Material Science and School of Physical Sciences, apart from service units that provide research felicitations, Central Scientific Services, Computer Center, Library, Workshop, etc. In terms of the input measured by funding per faculty member, IACS stands out in the publication of profile among all the research institutes of India as per the recent survey published by the journal Nature. IACS has a very high number of Bhatnagar awardees, J.C. Bose fellows, elected fellows of all the 3 science academics and other international award academics, including Third World Academy of Science. The research expertise at IACS has metamorphosed from traditional to translational in the areas of material science, material research, biological research, polymer, supermolecular chemistry, synthetic organic chemistry, bioorganic and organometallic chemistry, catalysis, cancer research, computational physics, chemistry, nanoscience, technology, quantum optics, atomic and molecular science, water purification sensors, and many other emerging areas of basic and translational sciences. IACS has created a sophisticated instrumental facilities such as LCMS, Transmission Electron Microscope, TEM, AFMs, Bed Surface Area Analyzer, NMR, MALDI-TOF, mass spec, pulse laser deposition, laser Raman spectrometer, high resolution X-ray, a single crystal facility, confocal microscopes, to name a few. IACS has recently built a technical research center from generous support from DST, which has been a significant step towards consolidating the molecules and materials research and translational work. The center has increased research collaboration in interdisciplinary areas and covers a variety of areas such as nanomaterial, quantum materials, functional polymers and other organic systems, materials with spintronics applications, strongly correlated electron systems, biomaterials, biology-inspired materials. The center encourages forging very strong partnership with the institute in the industries, and we are looking for more partnership in the industries. Now coming to the performance during the last 1 year, just in some parameters, the parameters that we use to measure our basic research. Last 1 year, we had 381 research publications in peer-reviewed journals and with a very high impact. There are 10 publications in book chapters. Our average impact factor happened to be 7.16, very, very high. So we have awarded 50 PhD degrees. There are 3 patents were granted and 5 patents were filed. IACS proposed to find and brand a new center of excellence, a smart campus at Baruipur, which will host the proposed deemed university under the de novo category. IACS plans to make its second campus functioning ongoing, opening up opportunities to build an incubator center, a technology park to set up the translational research under the Technical Research Center, or TRC, towards commercialization and to increase housing facilities to attract students and faculty members from other parts of the country. We also propose to expand schools of biological sciences and mathematical computer sciences in very near future. IACS envisages to taking part in the science development projects, policies, human resource development policies of the government. It is my great pleasure to be in the inaugural session of the Foundation Day celebration of IACS. I thank the organizers for planning a wonderful program scheduled today, which I'm sure will be liked and enjoyed by all. I look forward to the active and enthusiastic participation of all throughout the year and also in the years to come. Now I will formally introduce our guest who will present our Foundation Day lecture. I think most of you know him. So formally, it's my job to present him. Very brief introduction because he has a huge things to be said for him. So it's a great pleasure and great privilege and honor for us to the Foundation Day lecture for 2023 will be delivered by Dr. Shekhar Mande, who is a distinguished professor of Savitribai Phule Pune University, who needs no introduction since all of us know him as a prolific scientist, institution builder, science administrator, and a science policy maker, and of course a person believing in connecting science to society. Dr. Shekhar Mande is a structural and computational biologist. He was the director of general of the CSIR. Very recently he retired from there. And then prior to that, he was the director of NCCS Pune, which is a DBT Institute, AI. He was awarded 2005 Shanti Swarup Bhatnagar prizes for science and technology, the highest science award in India in the biological science category. Dr. Mande completed his MSc in physics from University of Nagpur in 1984. In 1991, he earned his PhD in molecular biophysics from IACS. Then he joined Professor Wim Hol as a postdoctoral researcher in Groningen in the Netherlands. Dr. Shekhar Mande began his professional career in December 1995 at the Institute of Microbial Technology in Chandigarh, MTech, what we called it. In September 2001, he moved to the Center for DNA Fingerprinting Diagnostics in Hyderabad as a senior staff scientist. From 2011 to September 2018, he served as the director of National Center for Cell Science in Pune, India, from where he moved to become DG CSIR. He has served in many national and international committees, including the Scientific Advisory Committee of the International Center for Genetic Engineering and Biotechnology, Trieste, Italy, the Management Council of Tata TIFR, Mumbai, member of the Council of Indian Institute of Science in Bangalore, member of Management Council of Solapur University and the Savitribai Phule University, member of governing body of the Indo-French Center for Promotion of Advanced Research, commonly known as CEFIPRA. Currently, he chairs the governing body of National Council of Science Museums. He is also the national president of Vigyan Bharati, a large voluntary science movement in India with the Make in India spirit. Until December 2019, he served as the chair of National Committee of International Union of Crystallography of the Indian National Science Academy in New Delhi. His research areas comprises of structural biology and X-ray crystallography, focusing on the structural characterization of Mycobacterium tuberculosis proteins, computational analysis of genome-wide protein-protein interaction and expression patterns, and many other emerging areas branching out of these. He has numerous honors and accolades, which include B.M. Birla Young Scientist Award in 1999, Wellcome Trust International Senior Fellow in 2003 to 2008, Shanti Swarup Bhatnagar Prize that I mentioned, Bharat Ashmita Award of MIT World Peace University Pune 2019, H.K. Firoda Vigyana Bhushan Award 2020, Aryabhatta Medal of Indian National Science Academy 2021, and many others. He is an elected fellow of all the three science academies. On a personal note, when I joined as a faculty at CDFD in Hyderabad in December 2001, he was there as a senior scientist and obviously as a mentor, as an elder brother. And me and people who joined during that time, we really were indebted to him to really guide in how to start a career, independent career as a scientist. So we shared lab spaces and spent many hours of discussing science and indulged in intellectual discourses also. I personally got huge support to build my career from him and I indebted to him. Thanks. So we fondly call him, especially in the Bengali community, as Shekharda. So thanks, Shekharda. I once again welcome the students and delegates, the dignitaries and all the participants, and thanks to the organizer for their untiring efforts over the last few days to make this event possible. Thank you very much. So now I invite, I call him Shekharda, so I am calling Shekharda instead of Dr. Shekhar Mande to give his lecture. Thank you, Shekharda. Slides.
Thank you, Ranjan, so very much for the very kind words. It's such a delight that so many people whom we have revered
revered through our careers are here. Especially it was very good to see Professor M.M. Sharma when we realized that he would be here at the lunch time. And so many other people whom we have known for many, many years are in the audience. So thank you all very much for your love and kindness and for inviting me to this particular talk on this day. Now all of you of course heard Professor Sharma and Ranjan, both of them, about the history of this place. But just to give you a small background from a very Swadeshi spirit, as Ranjan said, about why this institute was started in the first place. Many of you are aware that after the 1757 Battle of Plassey, when the East India Company was trying to put its foothold in the country, there is one difference that East India Company followed than the previous all aggressors in our country. Not one, but one of the differences. Most of the previous aggressors in the country came here, they settled down in India, they became part of our society. The aggressors which had won the 1757 battle had no such intention. The only intention was to basically rob us of all our wealth, our wisdom, and make themselves richer. That's one of the major differences. But from the science and technology perspective, the major difference from all the previous aggressors and the colonial powers of the last 190 years was they used science and technology as one of the weapons to rule over us. And there are many, many incidences that can be quoted how they did that. For example, one of the first ever science organizations that was started in the country was to map the entire geographical area of the country. And they started what is called as the Survey of India. Even today, Survey of India exists as an autonomous body or a subordinate office of the Department of Science and Technology in India. Survey of India's job was actually to go and survey entire land and try to see how that can be used for exploiting our natural resources. Very soon afterwards, the Botanical Survey of India, the Geological Survey of India, the Zoological Survey of India, the Meteorology Department, all of them actually started one after another, and it was in a way using science to be able to rule our population. There was no intention to bring modern science to India. There's absolutely no intention. And in fact, if ever, some of the most brilliant minds of that era were actually making contributions to the world, they were looked down upon in a very condescending manner. In Calcutta, I don't have to give you examples. For example, I cannot help giving examples. J.C. Bose, when he was offered a position to teach, he was given 1/3 the salary of what a British person would get, for the reason that Indians cannot think rationally, we don't have proper scientific background, and we cannot teach the next generation of students with the same rigor as the white man. At that particular point of time, J.C. Bose refused to accept salary. What becomes, as in our opinion, or in many people's opinion, as the first incidence of today what we call as Satyagraha. So the first incidence of Satyagraha was really J.C. Bose's refusal to accept salary, but yet perform all his duties correctly, go to the college, teach the students, build a next generation, until the British realized their mistakes some years later, and they corrected it and put his salary back on par with the Britishers. If this is not Satyagraha, what else is Satyagraha? So these are the kind of incidences that were happening all around us, and under those circumstances, there are a large number of people or a group of people, some outstanding people, who thought that India also must have its own place in the scientific world, or rather modern scientific world. And what we are celebrating today is a part of that. The foundation of Indian Association for Cultivation of Science was made with this view that Indians also must be able to come here and contribute meaningfully to the world of science. And what a difference it has made to the world.
The Indian contributions, almost all of them that you can think of in the early years, were made from this place, right? So what we should be taking pride, and we should be very grateful to the group of people who were at that time resisting, even the scientists who were resisting the colonial powers and trying to make Indian science and technology better and better. And what I want to do is essentially give you a few examples of what Indians have done over a period of time, since ages, since last several centuries, and how some of those practices are still in use even today. They are the examples that I would like to present to you, and how brick by brick our forefathers actually built the entire S&T ecosystem in the country to take on the colonial powers and tell the world that we are no inferior to others. So allow me about 25 minutes or half an hour to show you some examples. They are hand-picked examples. There are many other examples that can be quoted, but I have tried to keep the examples closer to Calcutta, most of them. So let us go through some of them. But before we do that, I thought what I will do is show you one outstanding contribution from this place, cultivation of science, and is for the benefit of the students, on a person called Kedareshwar Banerjee. Next slide, please. So, Kedareshwar Banerjee was, of course, one of the illustrious students of C.V. Raman. He worked here for a while. Then he went to Allahabad, University of Allahabad. He was a professor of physics there. From there, he moved to Dhaka, University of Dhaka. And then he came back to Indian Institute for Cultivation of Science as its director. But prior to all this, when he was still very young, he decided that he was going to look at structures of some of the compounds, particularly the aromatic compounds. And the mystery then, if we take ourselves to 1920s, okay, so mid-1920s, the structures of the first few inorganic molecules and even the organic molecules had started coming out. The first one, of course, you are aware, is that of Lawrence Bragg and William Henry Bragg, that solved the structures of cesium chloride, of sodium chloride, and so on and so forth. Very soon, Kathleen Lonsdale solved the structure of diamond, and so on and so forth. But the mystery remained how aromatic compounds look like. And Kathleen Lonsdale, one of the very, very illustrious crystallographers of early times, she suggested that to look at aromatic compounds, they are not very easily amenable to crystallizations, because benzene, for example, is liquid at room temperature, or liquid for most of the temperatures that we are accessible to, and therefore cannot be crystallized very easily. So Kathleen Lonsdale suggested that we should get hexa-substituted compounds of benzene, such as C6L6, or other compounds like anthracene or naphthalene, and attack their structures to understand something about the aromatic structures. And this is actually what she said, that C6L6, or by way of compounds such as naphthalene and anthracene, we should attack the problem on aromatic compounds. It is at that particular point of time, Robertson took up the structures of naphthalene and anthracene, and he published this. Robertson was a very close colleague of Bragg, and he published this particular structure. And what is most notable in this structure is that he says that these relations seems to afford strong evidence that the tetrahedral properties of carbon atom are maintained in aromatic structures. So the structure of naphthalene and anthracene that was presented to the world was tetrahedral carbon atoms of all carbon atoms in naphthalene and anthracene. And we know how wrong it is, because if each atom is tetrahedral, it would actually lead to pucker in the ring. It will not be planar. And that's exactly what Robertson suggested, that all atoms are tetrahedral. And in fact, he goes on to calculate bond length, which is much higher than the double bond length or something. By then, other students of C.V. Raman, notably Bhagwantam, actually had started measuring some of the magnetic anisotropy properties of naphthalene and anthracene, and they were getting somewhat contradictory results, that naphthalene and anthracene really don't look like that the carbons would be tetrahedral.
And they also tried to do optical anisotropy to show that magnetic anisotropy results were not really artifactual. And it is at that time Kedareshwar Banerjee stepped in, and he decided to attack the problem of solving the structure of naphthalene and anthracene once again within a year of Robertson's paper. And what he did and what he realized phenomenally is that the structure of naphthalene and anthracene is such that all carbon atoms necessarily are in the same plane. They are not tetrahedral. All of them are in the same plane. So naphthalene, the 2 rings, and anthracene 3 rings, they are all planar. This is not possible according to Robertson's structure. And he actually notes this in his paper, that the paper published on naphthalene and anthracene, Robertson comes to the conclusion that scattering centers are so and so, so and so, so and so, and he goes on dismissing the idea that it is not really so. What nature would do, now note the dates in the Nature paper. This is page number 456 on 22nd March 1930. What Nature would do? Nature, before publishing this paper, forwarded it to Robertson for his comments, that what do you think of this particular paper? And Robertson was asked to comment on this paper in the back-to-back thing. And Robertson came up in the same page number 456, 22nd March 1930, his rebuttal on Banerjee's structure. And read the first sentence. I believe Dr. Banerjee's structure to be essentially correct. So for the first time, the world was being introduced to the fact that in aromatic compounds, all atoms have to be in the same plane. Remember, the Debye-Hackel rule then, the 2n+1 rule that all of you are aware, was not yet formulated. It took another 3 years for them to formulate the rule. But the basis of all of that was Banerjee's structure, that suggesting that all the atoms have necessarily to be the same plane. Banerjee in fact went ahead and made calculations and then said that the diameter of carbon atom is about 1.42 angstroms. Diameter, essentially what we mean is the bond length between 2 carbons is about 1.42 angstroms, which is very close to today's bond length that we know in the aromatic compounds. All of you are aware that if the carbon has sp3, then the carbon-carbon bond length is of the order of about 1.52, 1.53 angstroms, wherein sp2 carbon is much shorter than that. And this is exactly what Banerjee went ahead and made the calculations. Now this is, remember, 1929, 1930, and it's just amazing, the foresight of Banerjee in this particular one. But then he went on to do even more fundamental contribution. In 1933, Banerjee proposed that the intensities of diffraction, or what we call as structure factors, they have some statistical relationships amongst them, and these statistical relationships can be used to solve the structures, crystal structures. And that's phenomenal. That's the first paper that Banerjee wrote, the equations among the relationships between structure factors, absolutely phenomenal. It took another 20 years for people to decipher all of this and come up with what is called today as the direct methods. And every chemist who is present in the audience who has ever solved a structure, right? Almost all the chemists would have solved a structure at a point of time, right? Every structure that is solved today is by the direct methods. And the Nobel Prize for direct methods went to Jerome Karl and Herbert Hopman in the 1980s. And Jerome Karl, in the opening sentence of his Nobel lecture, he says that the root of direct methods is in Banerjee's formula proposed in 1933. And that was from here, from Cultivation of Science. So we should be aware that what kind of profound work actually was being done by people at that point of time. And some of these examples unfortunately are not known because they are very specialized examples outside. We all talk of Ramans, or we also talk of many other people who are very celebrated. But some of these people should also be equally celebrated for their outstanding work, what they did in that particular point of time. What I want to do is, some of these I had already talked when I gave the Banerjee lecture here 4 years ago. But I want to come back to the biomedical sciences, which is more closer to my heart, and try to convince you that India's science has always been glorious over centuries, even continues to be glorious today, is only the fact that the recognition that all of us have around the world is probably not commensurate
what we ought to have. So let me start with examples of biomedical science, and I am going to start in about 600 BC. One particular tradition that is followed even today in the best of the hospitals around the world. Best of the best hospitals around the world, a tradition which is followed, the method which is followed was described, and I am going to give you some documentary evidences of that. And this method is what we today call as the reconstructive rhinoplasty. Now, if somebody's nose is broken, for example, then the method that has been described by Sushruta, 600 BC, is that you take a leaf, put it on the nose, cut it out with the shape of the nose, take the leaf either on your forehead or on your cheek, that shape of the skin you excise out of that, just switch it over on the nose, put 2 sticks in the nose so that that holes remain, and then stitch it there at that particular point of time. This method is even used today. You name a hospital around the world and this is used even today, right? Reconstructive rhinoplasty. And the photograph that I am showing you is for a purpose, a person called Kausaji. This person, I will tell you a story a little bit about this, about how this person actually came to be. And what happened was, this particular method first was eventually more detailed described by Vagbhat in the 4th century AD, and he actually gives each step by step what is to be done. And to avoid sepsis, of course, at that time he said that use ghee and honey, but today we actually use some other agents for that. Now the photograph of Kausaji that I am showing you was a particular reason, because in 1793, when the East India Company engaged itself with war with Tipu Sultan in Mysore, Kausaji was a bullock cart driver, and he used to ferry the British soldiers from Pune to Mysore and back. And in one such trip during the battle, Tipu Sultan's forces cut his nose. They cut his nose, and consequently he had to come back to Pune and have this particular operation, rhinoplasty. That is the first time the British were actually watching an operation in process. And it is recorded in the Royal College of Surgeons proceedings that how this particular operation was done particularly. And then this 1793, an operation was incidentally performed not by a doctor, not by a surgeon, but by a barber in Pune. So the practices actually ran in the family such that several generations could actually perform the same thing. And eventually the thing was taken to England, and the first reconstructive rhinoplasty in England was performed by Joseph Carpue, he is fellow of the Royal College of Surgeons, on 22nd October 1814. And he says that he has followed step-by-step protocol as Vagbhat has mentioned in his text. And then he said that the entire procedure took less than quarter of an hour. That is about 15 minutes. And the person who underwent operation was of course greatly in pain, and the reconstructed nose had every appearance of the natural nose, and the forehead took about 3 months to heal. So he had excised out part of the forehead and then put it here, and the forehead took about 3 months to heal. Now trust me, this process is followed even today. You go to the site of any of the leading world hospitals, whether be it Harvard or Cornell or wherever, and look at their plastic surgery departments and find out what do they do, and they would describe exactly the same process. So what we are talking is not pseudoscience, what we are talking is not witchcraft, what we are talking is not something without evidence. What we are actually talking is something which is very evidential. And what I often find, and this is the comment that I made recently in the Deputy Wellcome Trust India Alliance meeting, some of you are present here, that very often we find ourselves caught into a debate where all the modern practitioners of whatever we call science, technology or medicine or whatever continuously treat the ancient practitioners with a disdain, with some condescending remarks, and the people who are practicing some of the ancient practices do not come to the terms of the modern methods of science and medicine. Now both these are extreme positions in people, in the opinion of people like me. What we always promote is taking the middle path. What people like me have been talking about in the audiences general is that both sides have a great deal to learn from each other, and we are going to take some more examples. We have so much to learn from each other, both the modern practitioners of medicine and both the ancient people who have been following ancient traditions. Both of them, if you find a middle ground, I think it's only going to help mankind in the long term. Are you going to write about it? Okay. Yes. So basically we'll actually go through some more examples and we'll start coming closer to time and see how actually things have been. Now if you look at Indian traditional medicine, one of the things that actually is the use of plants or the plant derived products many times. And in the early days, and this is the thing that I will repeat once again a little later, in the early days of colonial occupation, or when the Western people were coming here for the commercial purpose, for developing commerce between the two states, whether the Europe and India and other places, there's a lot of exchange of ideas and a lot of healthy respect for each other. It's only once the colonial powers have settled down here significantly, it is at that time all the behavior which was abusive towards us actually began. But in the early time, of course, both the things were very, very respectful of each other. And that example, one of the examples that you see is in this particular treatise called Hortus Mulbaricus. Many of you would have heard it. So people who have from plant background would know about it. It is written by the Dutch governor at that time, particular governor called Hendrik van Reed in 1676. What he wanted to do was essentially catalog the medicinal plants in Kerala, and he was significantly helped by somebody called Itti Achyutan. He came from the family of traditional physicians, and he helped him generate this particular volume. Now remember, this precedes, Hortus Mulbaricus precedes the celebrated, what you know today, the volume by Linnaeus, which was written in 1753, almost 70 years later after this. So the first attempt to categorize plants from modern methods was made by Van Reed in Kerala in collaboration with Itti Achyutan, and actually very well laid out description about each plant and the medicinal properties and so on and so forth. So here you actually see two congregation of what the then contemporary people, contemporary science and the traditional science, how they came together and created something of worth the value at that particular point of time. So this is the kind of collaboration is actually what we should be looking at even in the modern times, is together coming and creating volumes like this. But I want to come to once again an example in Bengal, and this example is of vaccination. Now this precedes the vaccination against smallpox much later, 1797, but this actually is much earlier. So there was a practice in countries like China and India since about 12th century that every year before the pandemic came, and typically the pandemic would come in March, April, May, something around that particular point of time, that a group of people would travel from Banaras to all over the country. They would carry inoculum with them. The inoculum had to be at least 1 year old, so from the previous year's this thing, and they would actually bring it on a cloth or a cotton. They would absorb the inoculum. They would bring needles with them, and they would inoculate large percentage of populations. And this is typical variolation that you actually see here. So this is taken from the history account of somebody called John Holwell. I don't know how many of you have heard of John Holwell. He was the survivor of the famous black hole. All of you are in Calcutta. I don't have to tell you the significance of black hole. How far is it from here? Maybe 2 kilometers, 4 kilometers? 4 kilometers, right? Near Victoria. Holds a very special significance in history of Bengal. So John Holwell was a survivor of the black hole. He was a doctor himself, and he carried this particular method of variolation back to UK, and in presence of once again the Royal College of Surgeons, he made a presentation sometimes in 1750 or 1760, around that particular point of time. And one of the accounts of that has been captured in the journal called Medical History, is that in India the notion of popular resistance to smallpox prevention took a particular turn because variolation was well established in some regions, most notably in Bengal, and here came to represent a rival, not obviously inferior practice to vaccination. The vaccination Edward Jenner's vaccination came much later, and he is referring to that particular one. And initially, note this sentence, the British looked with sympathy and even admiration on the popular Indian practice of variolation, but after the advent of vaccination, they grew increasingly hostile, and by the mid 19th century, variolation was described as a murderous trade. Now this is unacceptable, because we are learning from the traditional practices of India and China, some of which have formed a basis or inspiration or motivation of finding new practices, directly out of which the vaccination arose. I don't think Edward Jenner's vaccination arose by accident. Obviously there was a lot of information exchange from the east and the west, and this was one of the examples in which one of the motivations also would have been this particular variolation practice at that particular point of time. So we must actually, once again, as I said, we must take a middle path in which both the sides agree and appreciate each other before we actually take any hard stands. And then of course it goes on and on about this, but a very good account is found in Holwell's presentation to Royal Society of Surgeons around 1750 or 1760, what he actually made a presentation there. Even closer to time, now we start coming to the modern, what quote unquote modern medicine. And one of the practices in India for a long time has been this plant called Sarpagandha. Sarpagandha was known to have hypotensive activity. If you have high blood pressure, if you give extract of Sarpagandha, the blood pressure comes down. Sarpagandha also is known to have some sedative properties. So people who have some sort of psychological breakdown or something, Sarpagandha is also given to those kind of people. Now someone called Colonel Ramnath Chopra, whom you see here on the slide here, he worked in the Calcutta School of Tropical Medicine. I don't know how far away is that from here again? 2 kilometers? 3-4 kilometers? Colonel Ramnath Chopra was the first trained in a modern sense pharmacologist of India. Incidentally, I mean just digressing from the topic, eventually he also wrote in 1940 what is called as the first Drugs Act of India, today what is called as Drugs and Cosmetic Act 1940, that was written by Colonel Ramnath Chopra. And incidentally, he is also the one who founded today what is called as the Indian Institute of Integrative Medicine in Jammu, what was then called RRL Jammu. So Colonel Ramnath Chopra was funded by the Indian Research Fund, which is a predecessor of ICMR, for clinical applications of Sarpagandha. And one of the reviews years later, P.N. Tandon, in the reviews, he noted that the courage to use this drug in clinical practice in an era when indigenous drugs were not generally used by the practitioners of modern medicine is commendable. It sounds very much like the present era, when the traditional medicinal practices are not accepted by modern medicine, is pretty much even reflects that today. So because of the efforts of Colonel Ramnath Chopra, Reserpine was developed as a drug to treat hypertension. And to tell you, hypertension, the second line drugs to even today is Reserpine. There are more powerful medicines which have come, they are the front line drugs to treat hypertension, but Reserpine is still in use as a second line drug against hypertension. And that comes directly from our traditional knowledge, from the knowledge that it's a hypotensive and it's sedative. Now what is more, because we know that it's sedative and we knew at that time that it is used to treat people with psychological issues. And why would it be sedative? And this mechanism of action was undertaken by Arvid Carlsen and Bernard Brody. Is there anyone who has not heard of Arvid Carlsen here? Are there students who have not heard of Arvid Carlsen?
He's the one who discovered dopamine and got Nobel Prize some about 10 years ago for that. But his first project was to understand the mechanism of reserpine, the same reserpine, the same reserpine, the same sarpagandha. And then he actually found out how it actually works on brain, and he realized that just like serotonin and catechols and all, it depletes amines from the brain. And that eventually went on for more discoveries of this kind, and he was, as I said, Arvid Carlson got Nobel Prize about some 10 or 12 years ago for his discovery of the same later. But the first project that he did and his motivation came from the mechanism of action of reserpine. Once again we see a beautiful congregation, a beautiful coming together of modern and ancient practices. Right? So when the two sides talk to each other, there is always something to learn from each other. This example, from the modern medicine perspective, a purely modern medicine perspective, is of, once again I have chosen from Calcutta, and that is of Upendranath Brahmachari, 1922, who discovered urea stibamine. When Upendranath Brahmachari actually did clinical trials and showed that it is a very effective anti-leishmanial, at that time the mortality rate because of leishmaniasis was 90%. The people who would get leishmaniasis, about 90% of the people would die. Over a period of 10 years, between 1925 and 1935, the mortality rate had dropped down to about 10%. Right? So the survival rate was 90%. What was the mortality rate? And this is from a purely modern perspective. There is not any traditions or something used in this particular one. But this essentially actually is the birth, we can say, of the modern medicine in India from the modern science perspective in a particular way. And historically, this is only the second anti-infective after salvarsan which is used against syphilis, and much before penicillin and sulfur drugs were discovered. This was once again done in the same college that we mentioned about Colonel R.N. Chopra, and the trials were done and showed that it is extremely effective against leishmaniasis. Now, I already finished about half an hour. I don't want to take too much time. I just want to touch upon two different examples. We will come to even closer to time now and see how modern biomedical science has developed post-independent. And we will also come to an example of a drug which has been introduced in the market about 4 years ago, and its Indian origin, a drug against tuberculosis. So these two examples we will see, and then after that we will stop. So I cannot but help take this example while I am in Calcutta, and most of the students would recognize, those who don't recognize, he is a gentleman called Shambhunath Dey, right? In an era when cholera had been discovered, and cholera was of course the cause of cholera, one of the early discoveries of that was made by Robert Koch, what it is due to, and that was sometimes in 1890s when he came down to India and observed under the microscope that is caused by a bacterium which is today we call as Vibrio cholerae. But how cholera actually develops and eventually leads to loss of electrolytes from our body, our gut, was not very well known. And most people thought they were actually endotoxins which were playing a role. But Shambhunath Dey did very systematic experiments at that particular point of time, and then he published a paper that is not an endotoxin but something called an exotoxin, some other factor that is secreted by the bacterium, which eventually binds to the epithelial cells in our gut. Once it binds to the epithelial cells in the gut, it is internalized, or part of it is internalized, and once that part is internalized, it triggers a cascade of reaction, what we call a cyclic AMP formation and so on and so forth. It actually adenylates what is called as GS alpha, one of the G proteins, and triggers formation of cyclic AMP at a very large scale, and that leads to the loss of electrolytes. So what you actually manifest when you get cholera or any of that kind of a disease, dysentery, in the loose motions or when you throw up, is essentially because the toxin has been internalized in our cells and it has triggered a reaction of adenylation, and then that has actually led to the loss of all the electrolytes from our cells and so on and so forth. But the responsible factor is the cholera toxin, and this actually changed the world like anything. Soon after the discovery of cholera toxin, many other bacterial species which have similar kind of effects. For example, E. coli. So the heat label enterotoxin of E. coli is something very similar to cholera toxin. Or pertussis, the exotoxin that exists in the Bacillus pertussis, that also is something very similar to this. So all the exotoxin discovery was triggered by the discovery by Shambhunath Dey at that particular point of time. And in fact, Shambhunath Dey was nominated for Nobel Prize at least 6 times by none other than Joshua Lederberg for the discovery of exotoxins and for actually starting this particular entire field of exotoxins at that particular point of time. The second example I want to give you, as I said, that we should be very proud of, is the drug that has been introduced about 4 years ago in the international market. US FDA gave approval about 5 years ago, this particular drug. It is called as pretomanid. It's a nitroimidazole. The starting compound is an imidazole, and then actually you have a series of compounds that were synthesized in the Ciba Geigy Research Foundation in Mumbai by one of the foremost and one of the finest medicinal chemists in the country then, somebody called Nagarajan. Nagarajan unfortunately passed away about 6 months ago at the age of 96. But nonetheless, he made series of compounds of this kind, and then in the 1980s, and then he noted some years later that if any of these compounds, either number 32 or 31 or both, if they succeed in the clinic, scientists of the Goregaon Research Park of Ciba Geigy, their wishes will be fulfilled. Now, completely oblivious to the fact that Nagarajan had done this particular work, and unfortunately Ciba Geigy had closed their research plant, a company in Seattle, Washington, took up synthesis of novel antimicrobacterials, and they actually synthesized a series of nitroimidazoles, and they came up actually with this particular compound and did clinical trials and so on and so forth. It's called pretonomid because the clinical trials were done in Pretoria in South Africa. Now recently when I gave this particular talk in DBT Wellcome Trust India Alliance, and I showed this particular slide, in the audience was one of my very close and old friends, David Sherman. David Sherman is one of the leading tuberculosis persons around the world. And David Sherman walked up to me after my talk and he said, Shekhar, I didn't know that this was synthesized in India. So I said, what did you think, where it was synthesized, the first one? He said it was in pathogenesis in Seattle. So I told him, tell me the date. He said mid 1990s. I said what we are talking is early 1980s. These compounds were synthesized in the Ciba Geigy Foundation by Nagarajan in the 1980s. 1983 is the first paper by Nagarajan, and he was not aware of it at all. I said, David, I am actually going to write about it in many places because the work done in India hardly ever gets any mention in the international press. As what we have seen, Shambhunath Dey did not get any recognition from around the world. Where around the world he was not even recognized in India what was due to him. And similarly, we saw J.C. Bose's example. We saw G.N. Ramchandran's example. The number of examples that even continue today, that for our work, we don't get recognition which is due from our Western colleagues. And we must talk about all of this. This is also our responsibility of our generation to go and talk that how this beautiful work has been done in India, but has hardly ever been talked about anywhere in the history of science in general. So, the only actually purpose of showing this particular one was what we used to do several centuries ago and what we have continued to do as a continuous practice over the years, over centuries, even continues today. Some of the finest work around the world is being produced somewhere here. Whether we get recognition for that or not is a different matter. But we should not get into the debate that the colonial powers had actually imposed upon us, that all traditions were a witchcraft, all traditions were a pseudoscience, all traditions were anti-science. That's a narrative which is promoted by the Western world, that is narrative is promoted by the colonial powers of India. And we must therefore take great pride in our traditions, we must take great pride in what has happened in India, whatever documentary evidence is available, and what we know today as modern science has derived actually on the shoulders of so many different discoveries that have been made through the ages, and we must take a great pride in that. And whenever we come across any such reference to India's traditions in science and all, we must stand up and say that not everything was witchcraft. not everything was pseudoscience. But there has to be a documentary evidence, and there has to be an explanation as we stand today from the modern science perspective in all these respects. So I should not actually fall shy of that, saying that everything that we should accept. But nonetheless, there are many, many things that what we have done gloriously, we must take a great pride in that. And lastly, one of the 5 holy plants mentioned in our Vedas is nothing but cannabis, right? And Atharva Veda actually calls the 5 most important plants, one of them is cannabis. Now cannabis of course has properties that it can also be addictive. There are 2 major compounds in cannabis, one is the THC, one is the CBD. If there is high THC, one gets addicted, but the medicinal properties are in the CBD. It has been used in India for several centuries. In 1985, unfortunately, there was international pressure on India to ban cultivation of cannabis, and we, unfortunately, the then government, yielded to that pressure, and we completely banned the cultivation and use of cannabis. And people like me see no reason why we ought to have banned. Cannabis has so many important cannabinoids, they can be used in medical practices even today. Some of the most effective painkillers are cannabinoids. In painkiller history, there are no compounds which can parallel the activity of cannabinoids. And cannabis has essentially been used for that particular purpose over centuries, as long as we make sure there is low THC. And one of my very proud achievements when I was in Delhi was to get one of the cannabinoids in clinical trials. We signed a MOU between the Department of Biotechnology, the ICMR and CSIR together, and we decided that we are going to get these cannabinoids in clinical trials. And in 2020, we actually started clinical trials, and here is the letter from DCGI then, permission for conducting clinical study entitled Clinical Effects of Vaporized Cannabinoids on Breast Cancer Genetic Expression Patterns in the Perioperative Period regarding so and so forth, and this is being conducted in Tata Memorial Hospital today. So I am very proud that we were able to actually force the government that not everything about cannabis is wrong, and in fact cannabis has very important medicinal properties, they ought to be exploited even today. This is the last of the examples that I wanted to give. What I want to say now, where are we and how are we going to continue contributing to the world? To be able to effectively contribute to the world of knowledge, we must have sufficient confidence in ourselves that we can also contribute at the highest level. That confidence gets eroded when your Western colleagues don't treat you on the same level. And the younger generation, I want to tell you that we are no less in our intelligence, we are no less in our resolve, and we must continue with that particular resolve that we are going to actually contribute as much as what the Westerners do to the world of knowledge even today. So don't please get bogged down if the Westerners don't give you recognition or so on and so forth. One day it will be talked about as our contributions. But for the future, if you look at an example of the Sustainable Development Goals, the United Nations announced Sustainable Development Goals in the Paris Agreement in 2015, and 17 sustainable goals have been developed. For example, Sustainable Development Goal is reduction in poverty all across. The goal 3 is healthy lives and well-being. Goal 5 is gender equality, and goal 10 is, for example, reduce inequality within and among countries and all. Now trust me, if any country which is on course to meet this, anywhere close to meeting this, I don't think any of the countries is on course to meet the 17 goals, but if any country in the world is making rapid progress towards Sustainable Development Goals, one of the leading countries is India. We had promised that our power generation would not be fossil dependent, or will make our fossil dependence of power generation less than 40%. That's what we declared in 2015. On today's date, our coal-based power has come down to about 33% or something. We are pretty much committed in meeting Sustainable Development Goals as other things. Who are the rogue nations? The nations which have done hardly anything towards meeting Sustainable Development Goals? Is the entire Western Europe, and is United States and in Northern America. They're all rogue nations. They have no commitment on meeting the sustainable development goals. What I'm showing you here, I deliberately showed you reduce inequality within and among countries. If you look at countries like the US and the Western Europe and look at how inequality has risen since 1985 or 1990 in these countries, is eye-opening. There's a modern economist, some of you would have heard of him, a French economist called Thomas Piketty. He has written a beautiful book. It says Capitalism in the 21st Century. He actually argues in that how in the modern world inequality has increased so much that if you count all the wealth in a country, who holds how many? Less than 1% people hold the maximum amount of wealth in the thing. And there are so many people who live in poverty even in those countries. India is different. India has not only made significant progress in our energy transitions, India is making significant progress in the reduction of our carbon footprint, but India has also made significant progress in reduction of poverty. And the statistics, those of you who have seen recently from the UNDP, now this is a source that I am quoting, I am not quoting any of our internal sources. Niti Aayog also has a similar statistics that India lifted 415 million people out of multidimensional poverty. 415 million, that's almost the population of Europe or almost the population of the US. Hasn't that been our achievement? How many people around the world are talking of our achievements? If you go to the West, do you see people saying that India is making so much progress? Our colleagues from the Western countries hardly ever recognize that we are committed to meeting sustainable development goals much more than most other countries actually are doing. So on ground, India is actually making very rapid progress in meeting sustainable development goals. We are very far off. We are about halfway through since 2015. The goals have to be met before 2030. One of the goals is reduction in temperature of the planet by about 1.5 to 2 degrees centigrade. I don't think we are meeting that. And the major weather change pattern that you are seeing around the world is because we are not able to meet that particular challenge of restricting our temperatures to about 1.5 to 2 degrees Celsius. So in the end, what I want to say is that we all must take pride of ourselves. We must take pride that we are a result of a very long cultural history. We have a very rich tradition on which we sit today. The Western narrative that we were a country of snake charmers and magicians is not correct. We have to correct that narrative on our own, and that narrative can only be corrected if we take pride in ourselves, if we take pride in our achievements. And this has continued as a long continuous tradition over a period of time, centuries, but also in the modern times, also in the post-independent times. And when we actually realize that we are capable of doing that, I have no doubt that even other countries will come around and start recognizing all of us. To finish, I want to show one slide where people actually often say that different governments have different agendas on science. I just want to remove that particular myth. Indian science has always been supported very, very strongly by the political powers and our society in general. I've shown you two quotes, one from Pandit Jawaharlal Nehru, one from Atal Bihari Vajpayee, just to show that political powers are with us, society is with us. Only connect if we have lost, if any, is our connect with the industry. And today we had a small discussion about that with a small group of people, that Indian industry, which was such an integral part of India's science and technology in the post-independent era, people like J.R.D. Tata, people like Khwaja Hamid, and all of them were so closely related to Indian science. For example, J.R.D. Tata was a member of CSIS Council for several years. J.R.D. Tata chaired the Research Council of National Aerospace Laboratories in Bangalore for a long time. So that connect that we have had with industrialists over a period of time perhaps has slightly lessened, and if at all, if we correct that, I think we have enough political will and political backing to pursue our objectives. So once again, to the younger generation, thank you all very much for listening to me, and take the world on with your confidence that we are no less than anyone else. Thank you all so very much.
Thank you very much, sir. On the occasion of Foundation Day, there were two competitions held. May I request respected Dr. Shekhar C. Mande to hand over the certificates. Winner for the photography contest is Mr. Shankar Kumar Chandra, IACS staff from library. Mr. Chandra, are you present? Okay, Mr. Chandra is not here. Winner for the painting contest is Ms. Shampurna Datta, BSMS student. Thank you, sir. Congratulations to the winners. Now I invite Ms. Sharbani Shah, Registrar IACS, to give the vote of thanks.
Good afternoon, everybody. As we are proceeding towards conclusion of the first session, let me offer my vote of thanks to the audience present here. The celebration of Foundation Day is an opportunity to remember the pioneering work of the past and an occasion to introspect about what more can be done. It reminds us of the quote of our founder, the great visionary Dr. Mahendralal Sarkar. The objective of the association is to enable the natives of India to cultivate science in all its departments with a view to its advancement by original research and with a view to its valid application to the arts and comforts of life. We may be repeating it too often, but this is a quote that our administrative ministry has always been praising, that such an objective, it covers all the past, present and future activity. So we always repeat it whenever we get an opportunity to speak. Even today, IACS is dedicated to the realization of the undying patriots. On this 148th Foundation Day, let us take a pledge to work earnestly for the growth and development of this institute from all aspects. We seek sincerest blessings and wishes from all our teachers, seniors, and well-wishers so that we succeed in our mission. The most important thing that we learned through our experience at IACS is that anything can be achieved with focus, perseverance, and confidence. Thank you to all for being outstanding colleagues and friends in our journey together. A heartfelt thanks to the organizers of the 48th Foundation Day of IACS for giving me this opportunity to speak in front of you. Thanks to each one of the members of the organizing committee under the chairpersonship of Professor Debashree Ghosh. Let us all feel and believe that we are in one of the best mission and profession and at one of the best institutions in the country. We feel honored to have Dr. Shekhar Mande as our Foundation Day speaker today, with whom we had so many varied kind of discussions in several groups throughout the day. We look forward to welcoming you again here, sir. The celebration and festivity would continue as we move forward to our cultural session with a flute recital by Ronu Mujumdar, who is among the most popular musicians on this instrument, and it's especially popular with the younger generation for his creative improvisations. Thanks to our director, like always, he has given us free hand to plan and organize, and we tried to deliver our best, and all of us and the special organizing committee, they wholeheartedly took part and planned each one step. And welcoming Professor M.M. Sharma here, it is like a family reunion for us. His coming always brings a whiff of confidence and elderly support to move forward in a right direction. Once again, congratulations to all of us, and I wish we will have some of the great years ahead. Thank you very much.
Pandit Ranu Majumdar is credited for making flute a popular musical instrument. The American musician and songwriter Ry Cooder has rightly said that he is definitely the Dr. Feelgood of the Indian flute. Pandit Ranendra Majumdar, popularly known as Ranu Majumdar, is a force to reckon in with the realm of Indian classical music, both as a thinking musician and a scintillating performer. Pandit Ranu Majumdar began playing the flute under the guidance of his father, Dr. Bhanu Majumdar, late Pandit Lakshman Prasad Jaipurwale, and finally the revered Pandit Vijay Raghav Rao. He was also fortunate to receive training from his grand guru, Pandit Ravi Shankar. A powerhouse performer, Pandit Ranu Majumdar is firmly rooted in the Maihar Gharana. He has been felicitated with numerous remarkable accolades for his mesmerizing performances worldwide. Ranuji has created an inviolable niche for himself in the field of contemporary popular music, which is exemplified by his Grammy nomination in 1996. Pandit Ramanu Majumdar has composed music for India's first IMAX film, Mystic India. He has conducted a concert of 5,378 flutists on one stage called Venunad. The event is recorded in the Guinness Book of World Records. Pandit Ranu Majumdar has been awarded the Sangeet Natak Academy Award for 2014 for his contribution in Hindustani instrumental music flute. Film Division of India has produced a documentary film on Pandit Ranu Majumdar called Masuri Wala. Among his other awards are the All India Radio Award in 1981, Aditya Vikram Birla Award 1996, National Kumar Gandharva Award 2006, Sangeet Natak Academy Award 2015, and Lifetime Achievement Award by Nav Bharat Times in the hands of Honorable Chief Minister of Maharashtra, Shri Devendra Fadnavis. Let us welcome Pandit Ranu Majumdar. Talent, virtuosity and youthful dynamism do blend in perfect proportion to project Shri Indranil Mollik as a leading tabla player of his generation. Intensive training since the age of 5 under eminent masters include Uncle Montu Mollik, Professor Dhabul Bandyopadhyay, Shri Uttam Chakraborty and currently living legend Pandit Shopun Chaudhary, has shaped Shri Indranil's rich repertoire and contributed to his reputation in the national and international era. Shri Indranil has also distinguished himself in crossover collaborations with Western musicians, including a recent project with Miles Davis Electric Band. Indian Radio and Television has awarded Shri Indranil A grade together with distinguished musicians of India. Lauded by connoisseurs and critics for his solo performances and accompaniment with renowned musician, Shri Indranil was the first tabla player to receive the prestigious Pandit Bhimsen Joshi Award in 2015. Let us welcome Shri Indranil Mollik. We will start our cultural program now. Thank you for joining us. Okay, and before we start, we would like to felicitate our guests. I would request Ankita Chakraborty to felicitate Pandit Ranu Majumdar. I would also request Dev Datta to welcome Panditji. request Ankita and Devdatta to felicitate Shri Indranil Mollik. Thank you, Devdatta and Ankita.
Namaskar to everyone. We are very happy to be with all of you this evening. I have played here before, I think 4 or 5 years ago, and enjoyed the vibes of the campus so much. I want to thank all the volunteers, especially the respected Registrar and Director Sahab, for giving us this opportunity. I want to start with one of my most loved rag, which I have not played since last many years, due to many reasons, due to many requests and mood and other things. I have not been playing rag jog since many years, though it's my favorite. So today I will start with rag jog. One of my friend has requested, and then let's see where I go. Alap. I don't need to explain much because it's Bengal. Everyone is deeply rooted into classical music. Alap is definitely unfolding the rag and kind of making portrait of the rag, picture of the rag. And then tal and rag combined together makes the music. Two main aspect of any music is swar and lay. Tal comes later. Lay is the whole world moves in lay. That is rhythm. Tal can be composed, but lay cannot be composed. Lay has to be within your system. And same with swara. So let's enjoy the vibes of this wonderful rag, rag jog, alap jod, and bandish in japtal and teen tal. And if mood goes, we might play a little bit of ek tal drut. Thank you. How is the sound? Is the sound okay? We are getting good here. কিছু কিছু জিনিস এসে যায় স্পন্টেনিয়াস, ভাবিনি যে এটা আসবে, আবার হওয়ার চেষ্টা করছি। খুব সুন্দর জায়গাটা দেখে, আহা মোকলাতে এসে পড়ছে, কিন্তু তেহাই লাস্ট নোটটা মোকলাতে এসে পড়া একটা ইউনিক কনসেপ্ট হয়, আর তেহাই শেষ করে মোকলা ধরা একটা কনসেপ্ট হয়। দু রকম কনসেপ্ট হয়। এর সেকেন্ড কনসেপ্টটা খুব আন্দাজ দিয়ে চলে। যোগ করনা मतलब मिलाना दो गंधार का मिलन দুটো গান্ধারের যোগ হয় যেখানে সেটাই রাগ যোগ কি সুন্দর রাগের ফরমাইশ করেছেন দাদা আহা এ দা গা মা গা মা পা মা পা গা মা গা নি সা গা গা মা পা গা মা সা গা সা গা pa ma ni pa ma pa ga ma pa ni sa ni pa ga ma ga ga sa ni sa ga ma pa ni sa ni pa ma ga ma pa ni sa ga sa ni pa ni pa ma ga ma ga sa ni sa ga sa ni pa ni sa ga pa ma ga ma pa ni sa ni pa ma ga ma ga sa ni sa ga ma pa ni sa sa ga pa ni sa sa ga pa ni sa একটু একতাল বাজাচ্ছি তারপরে আমির খান সাহেবের ওই তিন তাল कटत नाही दिन रहना कटत नाही दिन रहना कटत Ektal in Ektal, in a Jati system, bringing Ektal perfect inside the Ektal. Now we play Amir Khan Saab's composition and go to Jhala. আপনারা বোর হয়ে যাচ্ছেন না তো? ঠিক করে বলুন, আমরা লম্বা বাজিয়ে ফেলছি না তো? আজকে রিকোয়েস্ট ছিল যে একটু পিওরলি বাজাই, যেটা আমরা শিখেছি, তো সেই জন্য একটু নিজের জন্য বাজাচ্ছি আমরা। सजन मोरे घर आए सजन, पॉपुलर बंदिश, ट्रेडिशनल बंदिश। তিলক কামদেরও ফরমাইশ খারাপ না। निरभरन कैसे जाऊं सजनी अब, तिलक कामत। टॉस किया मैंने, टॉस ने ये कहा कि तिलक कामत सिर्फ 3-4 मिनट बजाइए, फरमाइश पूरी करिए, बी प्रोफेशनल सो दैट दे कैन कॉल यू नेक्स्ट टाइम ऑल्सो। कुछ लोग जो अपने लगते थे दरअसल वो पराए थे। कुछ लोग जो अपने लगते थे दरअसल वो पराए थे, और जो पराए थे वो तो पराए ही थे। क्या बात ये मैंने अभी लिखा अभी। और बांसुरी का काम नहीं चलेगा तो कम से कम लिख के आप लोगों को एंटरटेन करेंगे। क्या करें, जीना तो है। कभी इनका सुनेंगे, कभी आपका।
By the way, Runuda is a very good composer. लिरिक और सुर तो सब जानते ही है, लिरिसिस्ट भी है, तो जोरदार एक ताली हो जाए रुनुदा के लिए फिर से।
आप लोग इस तरफ मेरा दिल तोड़ के जाइए मत। अगर आप लोग खड़े होके बोल देंगे कि एक राग बहुत लंबा हो गया, साधारण फेस्टिवल का वो ज़माना चला गया, पता नहीं कहाँ चले गए वो लोग जो सारी सारी रात सुनते थे हमें, हमारे गुरुओं को, तो मुझे चलेगा। मगर इस तरह से हॉल खाली मत करिए प्लीज़, दिल में दुख होता है। अरे, वन ऑफ द greatest tabla player of our time, my younger brother, has come all the way. This has been our culture, to go to each other's concert, and Shubhajyoti Guha, you all know, such a handsome man, and he told me he will come, and he came. Thank you for coming. My student Anirban is here, he's sitting in the front, I could not see him. Please stand up. He came all the way from Siliguri, and he is from Kolkata. ও কলকাতারই ছেলে, কিন্তু ও বাসি শিখছে আমার কাছে। হি ইজ লার্নিং সিন্স লাস্ট 3 years continuously. He plays very well, and may God bless him so that he keeps continue knowing his improvement and his love for music, passion for flute especially. He plays very good guitar also. So I had a request of Hansadwani also. Let me see, both of them are so close actually. If I play Tilak Kamot, then Hansadwani will be boring. আচ্ছা, তিলক কামতটা একটু শোনাই তাহলে। এত সুন্দর রাগ বাঁশিতে বেশি শোনা যায় না, এজন্য যে চলনটা একটু ডিফিকাল্ট হয়ে যায় হ্যান্ডেল করা টেকনিক্যালি, সেই জন্যে তিলক কামত খুব একটা শুনতে পাবেন না আপনারা। তিলক শ্যাম তো মোটেই না। তিলক শ্যাম আমাদের গুরুজির তৈরি করা রাগ পণ্ডিত রবিশঙ্করজির তিলক কামত এবং শ্যাম কল্যাণ মিশিয়ে তিলক শ্যাম উনি বানিয়েছিলেন, ওটাও বাজাই আমি। এটা পুরনো তিলক কামদে কিছু কিছু জায়গায় কোনো কোনো প্রান্তে কোমলনি লাগানো হয় উপরের দিকে, তো ওটাতে কনফিউশন হবেন না। পুরনো বন্দিশকে ওইভাবে রেসপেক্ট করা উচিত যেইভাবে ওনারা বানিয়েছিলেন। তো এটা রাজন ভাইও খুব গান করেছেন, নীর ভরন कैसे जाऊं सजनी अब। डगर चलत मुसे करत नीर भरन कैसे, खूब सुंदर पुरानो बंदिश। तिलक कामत। traditional bandishes have some kind of very pure vibe. नीरा भरन कैसे जाऊं सजनी अब नीर भरन कैसे जाऊं सजनी अब डगर चलत मोसे करत रारब डगर चलत मोसे करत रारब नीर भरन कैसे जाऊं सजनी अब ऐसो चंचल चपल हट नट खट मानता न कहूँ की बात बिनती करत मोसे करत रारब अब नीर भरन कैसे जाऊं सजनी अब नीर रे रे मा ब ध मा ग रे ग स रे ग स रे ग स रे नीर একটু ওয়াতাপে শোনাচ্ছি যেটা লাগি लगन पति सखी संग नॉर्थे गावा है लागे लगन पति सखी संग लागे लगन सखी संग लागे लगन वातापिटा আপনারা ভাবছেন হয়তো হঠাৎ সোম থেকে নিলাম কেন কর্ণাটকে যখন গাওয়া হয় তখন ওরা সোম থেকে নেয় আর আমরা যখন গান করি লাগি লাগান তখন খালি দিয়ে দুটো কালচার আলাদা লা लागे लगनपति सखे संग लागी. This is ours. And Vatapi? Vatapi Ganapati bhaje hum, Vatapi Ganapati bhaje hum, কিছু সুর মাথায় এসে গেল, সেই জন্য আনসাধ্বনিটা বন্ধ করলাম। একটু ভাটিয়ালি শোনাচ্ছি, চলবে? আচ্ছা, অনেক প্রোগ্রামে তানপুরা লাউড হয়ে যায়, তানপুরা লাউড নেই তো? তানপুরার ভলিউম ঠিক আছে? এটা বাবার কাছে শিখেছিলাম, এটা পুরনো গান। জানেন গানটা? কেউ ইয়াস বলছে না। কীর্তনের দিক চলে গিয়ে চলে আসবো। থ্যাংক ইউ সো মাচ। আপনারা এতক্ষণ বসে একটা পিওর লম্বা বাজিয়ে ফেলেছি আজ রাগযোগটা, তবুও শুনলেন। আমরা সত্যি নিজের জন্য বাজাচ্ছিলাম। অনেক সময় এরম হয় যে আমরা অডিয়েন্সকে টোটালি ভুলে যাই, টাকাটা অডিয়েন্সই দেয়, তবুও আই এম সরি অ্যাবাউট দ্যাট। সামটাইমস আর্টিস্ট জাস্ট ফরগেটস এভরিথিং। থ্যাংক ইউ, সত্যি মন থেকে ধন্যবাদ জানাচ্ছি। আর এখানকার অডিয়েন্স সবসময় আগে বাজিয়েছি শুভজিৎ ভাইয়ের সঙ্গে। আর আপনারা ভালো করে মিউজিক শোনেন, আগেই কনফিডেন্স দিয়ে দেওয়া হয়েছে আমাকে সকালেই যে পিওর বাজাবেন, কোনো অসুবিধা নেই, সবাই শুনবে। শুনলেন আপনারা, থ্যাংক ইউ সো মাচ। প্লিজ প্লিজ
দর্শকদের তরফ থেকে এবং আমাদের আমাদের কাল্টিভেশন অফ সায়েন্সের যে অথরিটি, যে অ্যাডমিনিস্ট্রেশন, তাদের তরফ থেকে পণ্ডিতজি আপনাকে অসংখ্য ধন্যবাদ। অসাধারণ একটা সন্ধ্যা আমাদের উপহার দিয়েছেন এবং অত্যন্ত দরদের সঙ্গে যে রাগগুলো বাজিয়েছেন আমরা সকলে উপভোগ করেছি এবং আশা করব আপনি আমাদের ডাকে আবার সাড়া দিয়ে আবার আসবেন IACS-এ। আপনাকে আমরা স্বাগত জানাই। ধন্যবাদ, আপনাদের সকলকে ধন্যবাদ। ইন্দ্রনীল তো আমাদের ঘরের ছেলে, ওকে চেনেন সকলে, আর অবশ্যই ওর ধন্যবাদ তো প্রাপ্যই। ওর জন্যই পণ্ডিতজি এখানে হাজির হয়েছেন আজকে। ওই বেসিক্যালি IACS-এর ওই হোস্ট করেছে পণ্ডিতজিকে। ইন্দ্রনীল, থ্যাংক ইউ ভেরি মাচ।